Hey guys, welcome to Coding Spot and welcome to a new video where I'm gonna be showing you how to code this beautiful chess game from scratch. We're gonna be coding two different game modes. On the first part of this tutorial, we're gonna focus on the player versus player game mode. And on the second part of this tutorial, we're gonna code our own artificial intelligence to play against. Now this is gonna be super cool, however, it's gonna be a little bit complex. But don't worry, I'm gonna try my best as always to make you understand each line of code that we type. So yeah, this is the final result of the game that we're gonna code. As you can see, we can drag our pieces around the board. We're also gonna be able to change our background or our themes. So yeah, for this example, I coded 4 themes. So we have the green one, the brown one, the blue one, and the gray one, but we can create as many themes as we want. Also, we're going to be implementing sounds. So as you can see, each time I capture a piece, a sound is displayed. Now also when we move our piece, so let's say I move right here, we're going to get a different sound. Also, we're going to be coding a restart function, so we are going to restart our game whenever we want and we can start playing all over again. And finally, on the second part of this tutorial, as I told you, we're going to be coding an AI to play against. So I'm going to change the game mode to AI for you to see, but before that I want to open the console. I want to show you something. Okay, so I'm gonna press a key in order to change the game mode and we're gonna start playing against the artificial intelligence. I'm gonna go E4 and as you can see, AI answers with C5, the Sicilian defense. I'm gonna go with knight F3 and then I'm gonna develop my other knight. Now as you can see, finding best move is printed on console. Now these first two moves were book moves, so we didn't really use the minimax algorithm, which is the algorithm that the AI is going to use. They were just predefined moves. Now on the third move, we actually use the minimax algorithm. So we start finding the best move. So yeah, as you can see, we printed initial eval, final eval, and number of boards explored. Now, we're gonna go into detail of what an evaluation is when we code the AI, but I want you to see the number of boards that the AI explored in order to make this move. So in other words, from almost 8,000 boards, this was the best move according to our evaluation function. Probably this is not the best move in general, but according to our evaluation function, the evaluation function that we are gonna code, this was the best move. Now, as you can see, the number of boards, well, it's obviously variable and it is directly proportional to the time it takes the AI to make a decision. So yeah, it's pretty cool. We're gonna go into detail of these things when we code the AI, but yeah, this is the final result. So as I showed you a moment ago, we can play against another person. That would be the player versus player game mode, but we can also play against our artificial intelligence. So yeah, this is going to be a really long tutorial, but I think the final result deserves all the time and effort that we are gonna put on this project. So yeah, I really hope you like this tutorial. I hope I can do my best for you to understand each line of code. So yeah, now that you know what we are gonna code, let's start coding. Now before we start adding files or coding, I wanna actually show you the structure of our game. Now you can skip this part, but I strongly recommend you at least to see the classes that we're gonna use and have an idea of how these classes are going to connect between them in order to achieve the fully functional game. So yeah, feel free to skip this part if you want, but yeah, I'm gonna start explaining how are we going to structure our game. Okay, so this is a class diagram. So if you haven't seen one of these before, it's pretty simple. Each box represents a class of our application, in this case of our game. Now, each arrow represents a reference from one class to another one. So, for example, a board has multiple squares, and a square has 0 or 1 piece. So that's how we're gonna connect basically all of our application. So yeah, we're gonna start with this box right here. This is actually not a class. This is going to be just a file, pretty simple file. And we're gonna save the constants, like the main constants that we need for the game. So in this file, we're gonna save the width and the height of our screen. We're gonna save the rows and the number of calls of the board. This is obviously gonna be equal to 8. And we're gonna have a constant called square size, which is gonna be equal to either width divided by calls or height divided by rows. So pretty simple file. Now we're gonna start with our main root, which is our main class. Now the main class, it's gonna be long, but it's pretty simple. We're gonna have an attribute, which is the screen, and we're gonna have a method called main loop. So this method is gonna be huge. From this method, we're gonna call basically all the application. So this method it's quite complex. Now the main class is going to have a reference to our game class. Now game class is a little bit long also. We're gonna have two attributes. We're gonna have next player, so either white or black. We're gonna have a game mode, so PvP or AI. And we're gonna have these methods. So inside the game class, we're gonna have the render methods like show background, show pieces, show moves, show last move, show hover. We have a reset function, a change theme, a sound effect, next turn, change game mode, set hover, select piece, and unselect piece. So these methods are actually pretty simple. From here, let me show you, from here to here. So from reset to unselect piece, those methods are gonna be pretty simple. Now the methods that are gonna be more complex here are gonna be the ones that we have to render things. So all these show methods. Okay, let's continue. Our game class is going to have a reference with every single class pretty much. So I'm gonna start with the board. So a game has one board, obviously. We're gonna have two private methods, create, which creates the board, and add pieces. We're gonna have move. This method is going to be quite complex because it's responsible of moving a piece. Check for motion, valid move, and calc moves. This method is gonna be huge also. Okay, so what else? A board has also some references. It has 1 or 0 last move. So we're gonna save a variable called last move inside of our board, and this is going to be important because we wanna render our last move. We're also going to have multiple squares, so we're gonna have a reference to a lot of squares. If we want to be precise, we're gonna have 64 squares. So a board has 64 squares, and the square class is pretty simple. Its properties are gonna be row, column, so the row and column of the square, and alpha call. Alpha call is basically the column but represented as a char. Okay, we have some methods here inside of our square class. So we have has piece, has team piece, has rival piece, is empty or rival. So these methods basically return true or false if they meet some conditions. Okay, so from square we're gonna have a reference to a piece. So a square can have 0 or 1 piece. And the piece class is gonna be pretty simple. We're gonna have some attributes. So we're gonna have the name of the piece, the color of the piece, the value of the piece. Really important attribute. The moved, this is a Boolean attribute. The texture of our piece, the texture rect of our piece. This is a Pygame rectangle, and we're gonna have two methods: add a move and set texture. So pretty simple. Now from this class, there are gonna be some classes that are gonna, well, inherit. So obviously we're gonna have the pawn class, which inherits from piece. If you don't know what inheritance is, it's basically that the pawn class, it's gonna have the same as the piece class, but we're gonna add some other things to it. So in the case of the pawn, we're gonna have an attribute called direction. We have the knight class, the bishop class, the rook, the queen, and the king class. So yeah, it's pretty simple. We're gonna put all these classes in one file. Okay, what else? A piece has a reference to a move because, well, a piece has a lot of moves. And by moves, I mean valid moves. So I'm gonna put valid moves. So a piece has a lot of valid moves. This class is responsible of saving a move. So where is the initial position of the move and where's the final position of the move? So as you can see, we have a reference to a square, which is a initial, and we have a reference to a square, another reference, which is final. With the initial and the final squares, we have a move. Okay, let's continue. Game class, it's also going to have a reference to our square, to our square class. We're gonna have also a reference to our piece class, and that's it. Now let's go to this side of our class diagram. Okay, so the game class is going to have a reference to the AI class. A game is going to have one AI, and the AI class is going to have the following attributes. We're going to have an engine attribute, which is going to be equal to either book or minimax. So it's basically if we are using the book or we're using the algorithm to determine the best move. We have a depth or the level of the AI. We have the color of the pieces of the AI, and we have an attribute boards explored, which is the attribute that I previously showed to you that was being printed on console. Now we have some methods. These methods are going to be complex, are going to be hard, because this is where we are going to implement the artificial intelligence. So we have an eval method, we have a minimax, which is the algorithm, huge method. We're going to have a heat map, which is responsible of telling us the best positions of a specific piece. We're going to have a threads method, and we're going to have a book move and get moves. Now, book move is going to call the class book. So AI has a reference to book, and book, it's basically a book, literally, where we're going to predefine, or we're going to have predefined moves. So we're going to create the book, and we're going to have one method called next move. Now, inside of next move, we're going to have this class node, which I don't really know. I don't think we're going to code this. Like, I'm not even sure we're gonna use a book. Like, that's the problem. I think we're gonna just use the minimax. I don't think we're gonna use book moves, but we'll see. But however, a node is basically one move of the book moves. So yeah, I know it's a little bit confusing, but as I told you, I'm not sure if we're gonna code these two classes. Okay, let's continue. Our game class, it's also going to have a reference to our dragger class. The dragger class is going to be responsible of dragging the pieces. So if you remember, when I show you the gameplay, we were able to drag a piece around the board. This is the class responsible for that. It's actually pretty easy. It's not so complicated. We're going to have some attributes: dragging, mouse X, mouse Y, initial row, initial call, and we're gonna have some methods: update bleed, update mouse, save initial position, drag piece, and undrag piece. So yeah, and lastly we have all the configuration classes. So the game is going to have a reference to a class called config. Config is going to have an index. We're gonna see what this is when we are coding it. We're gonna have a font, the font of the game. We're gonna have a private method add themes, and we have a method change theme, which is connected to this method change theme, as you can see. Okay, from config, we have multiple themes, and a theme has 3 references to color. Why? Because a theme has a trace color, a background color, and a moves color. We're gonna see what's that when we code it. Now the color class, pretty simple, just has a light color and a dark color. Now the last reference is from config to sound, so it has 2 references, move sound and capture sound. And the sound class, it's pretty simple. We're gonna have the path of the sound. We're gonna have the actual sound object, which is a Pygame sound, and we're gonna have a method called play, which is basically responsible of playing this sound. So yeah, this is the structure of our game. I think it was pretty important for me to show you first how are we going to organize our code. Now we're not gonna follow this structure exactly as it appears here, because obviously we'll start changing some things and we're gonna have problems. And as I told you, I think we're not gonna use the book and node class. We're just going to code the minimax function, because this is not AI. This is not AI, and well, the idea of implementing the artificial intelligence is to use AI. This is predefined moves. So yeah, make sure to pause the video, see all the classes, and more or less understand this structure, understand the connections between the classes, and now we're ready to start coding our game. Okay, so the first thing is to make sure you have Python, Pygame, and any text editor installed on your computer. If you don't have any of these 3 things installed on your computer, make sure to see my videos where I explain how to do that for Mac and Windows users. Now, once you're ready, make sure to create a new folder. I called mine Chess AI. I'm gonna use VS Code as my editor, but you can use whatever editor you want. So we're gonna start by creating our constants file. So go ahead and type const.py, and we have our first file. Okay, before we start coding it, I want to create a folder. I'm gonna call it source. This is where we are gonna store all of our classes. So I'm gonna put our const file right here, and inside this file we want to create the following. So we're gonna create the screen dimensions. So screen dimensions, we're gonna have a width. I'm gonna use 800 pixels, but you can play with these values, and I'm gonna have a height of 800 pixels. Make sure these 2 values are the same because we wanna have a square. Now we're gonna have also our board dimensions. Right here, we wanna have the columns, which is gonna be equal to 8, and the rows, which are gonna be equal to 8. And as I told you, we're gonna have a square size constant, which is basically width divided with double slash, because we want it to be an integer, divided cols. You can also divide height by rows, it will give you the same result. Okay, and that's all. That's our first file. So now we're gonna create our main file, and we're gonna import these constants that we just created. So go ahead and type main.py. Inside of this file, we're gonna have our main class. So in order to create our main class, go ahead and type class main. Right here, we are gonna create our init method. I'm gonna explain what this is in a moment. We're gonna receive self as parameter, and we're gonna pass it. Now we're also going to create a method called main loop. So this is the method like pretty much responsible of calling all other classes. We're gonna receive also self as parameter, and we have our main class. Now at the bottom of the file right here, we want to create an instance of this main file. So go ahead and type main equals main. So main is the object, main is the instance of the main class. And now that we have an instance, we can call our main loop. So go ahead and type main.main loop. Now this init method is always called when we create an object. So when we created this main instance, the first method that's being called is the init method, and then we're calling the main loop, as you can see. So if I print something, so let's say hello, and right here I print world, and I hit run, I run my file, you can see we have hello world, hello being printed first on console. So this init method is always going to be called first. Now once that we have this, we can go ahead and start importing the models that we are gonna use. So go ahead and import Pygame. The Pygame model. We're also importing the sys model. This is gonna help us quit the application, and we're gonna import our constants. So go ahead and type from const import all. Now we have access to the constants that we previously created. Now inside of the main class, we're gonna create our screen. That's the first thing we want to do, our Pygame screen. So in the init method, go ahead and type pygame.init. We are initializing our Pygame model. So we always have to do this when we are working with Pygame. We want to initialize it. Now we're gonna create the screen attribute. So go ahead and type self.screen. So each time we want to create an attribute or a property of our class, you have to create it with the self keyword. So self.screen. And this is going to be equal to pygame.display.setMode. And inside here, we want to pass a tuple with the width and the height of our screen. So these are the constants that we previously created. And this line of code is basically creating a screen, a Pygame screen, and we are saving it on a variable self.screen. Now we're gonna set up the caption. So go ahead and type pygame.display.setCaption. So set caption, and we're gonna call it chess. This is the caption of the application, and that's all for now. Now inside of the main loop, we're gonna create the following. So these first lines of code, as I always say on my tutorials, are always the same, so don't worry if you don't understand these things. This is basically how we are going to set up a Pygame file. So go ahead and type while true. So this is our main loop, and right here we're gonna loop through all the events, through all Pygame events. So for event in pygame.events, pygame.events.get, we're gonna check if the event dot type is actually equal to pygame.quit in order to call the pygame.quit method and also the sys.exit method. So as I told you, you don't have to understand this, but we're basically looping through all the events. So click events, key press events, mouse motion events, and we're checking if the user is actually quitting the application. So if it's clicking on the X button. So yeah, pretty simple. Now at the end of the main loop, so right here, we want to type the following: pygame.display.update. This is going to update our screen. So make sure this is the last line of code inside your main loop. And also make sure this line of code is outside of the for loop. So it has to be inside the while true, but outside the for loop. Now we can run the file. You can save it and run the file, and we should see a screen being displayed. Okay, so we have an error. Events. Yeah, my bad. It's not events, it's event. So for event in pygame.event.get. Now if you save, we should see our screen. So as you can see, we have a screen of 800 by 800 pixels, but obviously we have it empty. So let's start doing some things with that screen. So the first thing that we're gonna do is to render the background. So we're gonna have the chessboard being displayed on screen. So for that, as I told you, we're gonna create a game class, which is responsible of all the rendering methods. So go ahead and create the class, the game class. So class game, and inside we're gonna have the init method. We're gonna receive self as parameter. We're gonna pass it for now, and we're gonna have a show background method. We're gonna receive self as parameter, and we're also going to receive a surface, and we're gonna pass it for now. I'm gonna put a comment right here telling that these are gonna be our show methods. Now this surface that we are gonna receive as a parameter is going to be the self.screen that we have created right here. So inside of this method, we're gonna draw the board basically. So first of all, we're gonna import Pygame again. We're gonna import the constants, so from const import all, and now we can do the following. We can do a double for loop, so we're gonna type for row in range rows. So we're gonna loop all the rows of our board, and inside of that we're gonna loop all the columns of our board. And right here we wanna draw the pattern of the chessboard. So as you know, a chessboard has one dark square and one light square, then one dark square, then one light square, and so on, so on. So in order to do that, we're gonna use an if statement. So go ahead and type if the row plus the column model 2 is actually equal to 0. We are going to create a color variable, and this is going to be equal to 234, 235, 200. So this is a green color. This is the light green color. You'll see in a moment. But if that's not true, so if row plus col, and by the way, this is row and col, model 2 is not equal to 0, then we want to set our color to be equal to 119, 154, 88. So here is model 2. Okay, so this is the dark green, so I'm gonna put it right here, light green and dark green. We're then going to save these colors in our theme class, so don't worry for this. But for now, I want you to show that this actually works. Okay, so once we have this color variable, we're gonna go ahead and create the rectangle that we are gonna actually draw. So a Pygame rectangle, by the way, I'm gonna call it rect. So a Pygame rectangle has 4 params. It's a tuple with 4 parameters. The first one is going to be where we are gonna start on the x-axis. So we want to start in the column times the square size. The second parameter is going to be where we want to start on the y-axis. So that will be row times square size. Square size. And the last 2 params are going to be the width and the height. So that's basically square size, comma, square size. So like this. This is how you should have the rectangle. So pretty simple. Now, once we create the rectangle, we can actually draw it on screen. So go ahead and type pygame.draw.rect. We are going to pass 3 parameters. So let me show you this method. So as you can see, it receives a surface. Right here, it receives a color. So a surface, a color, and a rectangle. So we're going to pass the surface, the color, and the rectangle. And that's it. That's our method for now. So inside of the main file, we can go ahead and import from game, import game, which is the class. And inside of the init method, we're going to create a new attribute called game. So we're making the reference from our main class to our game class. And inside of the main loop, we want to type the following. Right here, we want to type game. self.game dot show background. So right here. So each time we loop, remember this is an infinite loop, so it's always like looping through this, we're going to show the background. So I'm gonna run the file and I'm gonna see what happens. Okay, oh yeah, we're missing the surface. So as you know, our method show background receives a surface. So we're gonna send our self.screen. And now it should work. And as you can see, we have an awesome, a beautiful chessboard being displayed on screen. So we have our board, we have our graphic board. We need to create the console board, but we now have the graphic one. So pretty awesome. Now I want to do something before we continue. So let me explain to you. Inside of this while loop, we're gonna use a lot our attributes, our main attributes. So the game and the screen. Now I don't want to type self.game each time we wanna call the game, and self.screen each time we wanna call the screen. I just wanna type game or screen. So outside the while loop, we're gonna create two variables. One is gonna be game, and this is gonna be equal to self.game, and the other one is gonna be screen, and this is gonna be equal to self.screen. So now we can use game and screen instead of self.screen and self.game. This is gonna make our code look much more organized. Now if I run the file, you'll see it works. So yeah, pretty cool. We have the graphic board. Okay, so the next thing we're gonna do is actually add some pieces to our board. So I want this empty board to have some pieces rendered on top of it. So let's go ahead and do that. For that, we're gonna create the piece class, the pawn, the knight, the bishop, the rook, the queen, and the king class. We're gonna also create the square class, because remember, if you see our structure, let me see right here, the square is the one that has some pieces. So we're gonna basically, let me show you, we're gonna I think we're gonna create these three classes. Well, the basic things of these three classes in order to render the pieces correctly. So okay, let's start creating our square class. We're then going to create our board class, and we're then going to link our game class to our board class. So let's start creating our square. So go ahead and create a new file, square.py. We're gonna create the class square. We're gonna have an init method which receives self as parameter, row, call, and piece with a default value of none. So let me explain to you what's this. So we have our self keyword, we have the row and the column of that specific square, and we have an optional parameter which is piece, because remember, if you see the square class right here, it's gonna have 0 or 1 pieces. So not all squares are going to have a piece, obviously. That's why we set it a default value of none. So inside of our init method, we're gonna type self.row equals row, self.call equals call, and self.piece equals piece. And that's all for now. So I'm gonna leave this class right here. And now we can create our board class. So go ahead and create a new file, board.py. We're gonna create the class, so class board. We're gonna create the init method, and we're gonna pass it for now. And we want to import from const import all. So we're gonna import all constants. Now inside of the board class, we're gonna start by creating two methods. The first one is the create method. We're gonna receive self as a parameter. I'm gonna pass it for now. And we're also going to create an add pieces, which is going to receive self as parameter and a color. And we're gonna pass it for now. So if you're asking yourself, why did I put this underscore before the name of the method? Is because I want to somehow show that these methods are private methods. So we're gonna call these methods just inside of our board class. So inside of our init method, I want to first create a new attribute for the board, which is gonna be squares, and this is gonna be equal to an empty list. So remember, our board has a lot of squares right here. So inside of our create method, I want to do the following. So go ahead and type self.squares. We're gonna initialize this list. So let me tell you how we are gonna do this. I'm gonna first code it and then I'm gonna explain it to you. So I'm gonna add 8 zeros. 4, yeah. So I'm gonna add a list of 8 zeros. I'm gonna type for call in range calls. So let me explain you what this does. And actually I wanna print this for you to see. Self.squares. And I'm gonna call it right here. So I'm gonna create a board instance and I'm gonna call the create method. So create method. I'm gonna run the file and you should see our console board. Now let me explain these lines of code. So we're basically creating a list of 8 zeros for each column. So try to visualize the board. I'm actually going to run it for you to see. So for each column, we're going to add a list of 8 zeros, and that's gonna be our column, as you can see. So for each column, we're adding a list of 8 zeros. So I hope that's a little bit more clear. So yeah, once that we have created our board, our console board, we can loop it and we can start adding our squares object, because we don't want to have zeros inside of our board squares. We want to have actually squares. So go ahead and type for row in range rows and for call in range calls. We're gonna type self.squares in the position row, in the position column. So we're accessing each one of our squares that we created right here. We're accessing these zeros. Now, instead of having a 0, we're gonna set a square, a new square. So first of all, we're gonna import from square, we're gonna import square, the square class. And now we can do the following. Square is equal. So remember, we have to pass a row, a column, and a piece. So we're gonna pass row and call. Now the pieces, we're gonna do that inside of this method. So for now, we're just creating a board full of square objects. And actually, I wanna get this line of code. Instead of having it here, I want to have it on our init method. So here we are creating basically a 2-dimensional array, and here we are looping that 2-dimensional array and we are adding a square object instead of a 0. So hope that's clear. Now inside of our init method, make sure to call that create function or create method that we just created. Now we're gonna add the pieces. So for this, we actually need to create our piece.py file. Because remember, let me show you, a board is going to have multiple squares, and each of those squares is going to have 0 or 1 pieces. We already did the part where they don't have pieces right here. But now we want to add some pieces to the squares that actually have pieces. So those will be the first 2 rows and the last 2 rows. So before we actually add the pieces, let's create our piece class. So go ahead and type class piece. As always, create your init method with a self, with a name. So this is the name of the piece, the color of the piece, the value of the piece, the texture of the piece, and the texture rect. We'll see what these 2 things are in a moment, and this is gonna have a default value of none, and we're gonna pass it for now. And down here we're gonna create all the classes that inherit from piece. So we're gonna create the pawn class, the knight class, the bishop class, the rook, the queen, and the king class. So it's pretty simple, don't worry. We're gonna create our pawn, and in Python, in order to tell that this class inherits from this one, we want to put brackets, and inside we want to put the mother class. So pawn inherits from piece. So right here we want to create also our init method. But if you see, our pawn class is going to have a direction. Why? Because pawns, different from other pieces, have a direction, only move in one direction. So right here we're gonna receive the color, because with the color we know in what direction the piece or the pawn is moving or should move. So we're gonna do something like this. If the color is white, the self.direction, so the direction of that pawn, is gonna be equal to -1. Now remember, in Pygame, let me show you, coordinates work a little bit different, because the x-axis it's okay, it increases to the right, but the y-axis increases going downwards. Now the white pieces, we're gonna have the white pieces on this section of the board right here. So we wanna tell the pawns that their direction is gonna be -1, because we wanna go up. So the same thing with the black pieces. The black pawns are going to have a direction of +1 because we want them to go down. So hope that's clear. I'm gonna go right here. So if the color is white, our self-direction is -1, else our self-direction is +1. Now this if statement, we can actually code it the following way. So go ahead and type self.dir equals -1 if color equals white, else 1. So this line of code and this if statement are pretty much the same. I'm gonna use that one because it's shorter. Now we're gonna call our piece class init method from here, because we want to initialize our values. So go ahead and type super.init, and let me actually explain. So we're calling the super init, so super will be our piece, and this is the init method. So remember, we need to pass a name, a color, a value, and a texture. Now by the way, the texture is also going to have a default value of none. We'll see what this is in a moment. So okay, for now we're gonna pass the name. So the name, we can hard code the name pawn. We can pass the color, so that will be the color that we receive as a parameter, and we are going to pass a value. So the pawn is going to have a value of 1. This is a really important attribute for our AI, because our AI is going to evaluate the board based on these values. So we're gonna pass a value of 1. Now we're gonna do pretty much the same for each other class. By the way, the pawn class is ready, so I told you it was gonna be pretty simple. Now we're gonna create our knight class, which inherits from piece, and we want to do pretty much the same, but we don't want to have this direction, because knights can move in any direction, right? So we're gonna call the super init with knight, and we're gonna pass a value of 3. By the way, these are real values. Like if you search for the chess pieces values, you'll see that pawn is 1, knight is 3. Now we're gonna create another class. I'm actually going to copy these, and we're going to create the bishop class, which inherits from piece, and the same thing, but right here we want to change this for bishop. Now bishop has also a value of 3. However, I want to make it a little bit higher than our knight value. You can leave this as 3, but I'm gonna use 3.001. So I'm just telling, like, the AI, when we code the AI, I'm telling the AI, okay, bishops are a little bit more important than knights. Okay, I'm gonna copy these a couple of times. So let me see. Right here we're gonna have the rook class, and right here we're gonna change the name to rook, and the value of a rook is gonna be 5. The bishop, we want to change this to queen, also this to queen, and the value of a queen is gonna be 9 points. And we have the king, inherits from piece, name is king, and the value of a king is going to be a super high value. So you can use math.infinity, but I'm gonna use something like 10,000. So this is going to tell our AI like, okay, the king is the most important piece of the board. You cannot lose it because you will lose the game. So okay, I think we're ready. We have our classes and we have our main class, which is the piece. Now inside the piece class, I want to do the following. I want to set the name, the self.name equals to name, the self.color equals to color. So for the value, I'm going to do the following. I'm going to check if the color, but I'm actually going to use these if statements that we can write it on one line of code. So we're going to create a variable called value sign, and this is going to be equal to 1 if the color, if color is equal to white, else -1. Why? Because we want to have you'll see this is gonna make sense when we code the AI, but black pieces are going to have negative values and white pieces positive values. So right here we can assign our self.value, and it's gonna be equal to the value that we're sending, so this number, times the value sign that we just created. So hope it makes sense. Okay, let's continue. Right here we're gonna create our texture. So we're gonna have a method for that. We're gonna call it set texture. We're gonna create it in a moment. And right here we want to put self.textureRect textureRect equal textureRect. What? Oh, texture. I missed the X. We're also going to put the self.texture equal to texture, and then we're gonna call this method. So let's create it. Set texture. I'm gonna pass it for now. Okay, so I hope you have understand what we've made so far. You'll see it will make sense once we have finished this adding pieces method. So remember, we're doing this because we wanna add the pieces to our board. So okay, the texture is going to be the path where we can find the actual image of the piece. So texture, you can call it image, it's gonna be pretty much the same, or URL, image URL. So as you can see, we don't have any folder where we can find the images. So we're gonna find those images on the repository, on the GitHub repository. So I'm gonna leave a link on the description below, and you should see something like this. Now if you see the final, this is the final project, and the final project has a folder called assets. So we're gonna download this assets folder. So right here, make sure you see the assets folder, and right where it says code, go ahead and download the zip. So you're basically downloading the final project. We're not gonna use it, we're just going to use the assets folder. So go to your downloads, or wherever you download the zip file, and double click on it, and then you have access to this assets folder. So as you can see, assets folder has images and sounds, and as you can see, inside of the images folder we have two other folders. So go ahead and take this assets folder and just put it on your project. So let's say copy folder. Yeah, so copy folder, and as you can see, we have access to our assets. So as I told you, we have some images, we have some sounds. So yeah, pretty cool. Now in the set texture method, we can actually access our images folder. So right here, go ahead and type self.texture. It's gonna be equal to, and we need a model for this. So go ahead and import us. So right here, go ahead and type us.path.join. And right here, we want to pass the path where we are going to find that specific texture. So the path is going to be the following. Put an F, and inside of these quotation marks, go ahead and type assets slash images slash images like this, hyphen, open these brackets. We're basically telling Python that we are going to add a variable right here. Oh yeah, by the way, the set texture is going to have a default param, which is going to be size equal to 80. So right here, we're going to pass size. Then pixels like this, slash, open brackets, self.color, underscore, self.name. I'm going to explain what we are doing. .png. So make sure your file, your URL, looks something like this. So let me explain you. Now we're accessing assets, so right here. Then we're accessing images, so right here. Then we're accessing either images 80 pixels, right, or 128 pixels. That we'll see later why we need those. So in this case, it will be these ones. And then, as you can see, we have our images named the following way. We have the color underscore the name.png. So as you can see, it's pretty much the same. The color underscore the name.png. So that's why the URL is like this, the path is like this. Okay, so we pretty much finish this class. Like, we're missing one method, which is, I'm gonna actually create it, add moves. We're gonna receive self and a move as a parameter, but it's pretty simple. We're going to append this move. We're gonna append the move to our moves attribute that we haven't created yet. So append move. And that's all. So pretty simple method. This is literally all this file. We don't need anything else. Now let's create this, where is it? This attribute. So right here, I'm gonna type self.moves. This is gonna be equal to an empty list. And we're gonna have a Boolean value called moved. And this is gonna be default to false. Now you can call moves also valid moves. So by moves, I mean valid moves of that specific piece. Okay, so we have our piece class ready. Now we can start adding the pieces to our board. So this is the cool part. You'll see that this board, let me show you, this empty board is gonna start having some pieces. So pretty cool. Let's go to our board class, and right here we want to do the following. So the first thing we want to check is the color. Now remember I told you, let me actually show you something. Remember I told you we're gonna put the black pieces on the first two rows and the white pieces on the last two rows. So we can actually save those rows into variables. So we're gonna do something like this. So if color is equal to white, we're gonna have a row pun variable, comma, a row other variable equal to a tuple, which is 6, 7. So let me explain. Row pun is gonna be equal to 6 and row other is gonna be equal to 7 when the color is white. Why? Because, let me show you, this is the row 7. So here we want to have the white pieces, and this is the row 6. So here we want to have the palm pieces. So that's why we do that if statement. So right here, else we want to have row pun, comma, row other equal to, you say it, 1,0. Now try to put this if statement as this, because we're gonna use this kind of if else, because they just need one line of code. So try to convert this if else statement to this structure, and it will be something like this: row comma row pawn comma row order is gonna be equal to 6,7 if the color is white, else they are gonna be equal to 1,0. So we can delete this if else, and we're gonna stay with this one. So pretty cool, pretty simple. Now we're gonna do the following. We're gonna start adding the pawns. So for call in range calls, so we're gonna loop through each column. We're gonna put self.squares in the row pawn. So we're gonna use here the pawn. Then in the column, remember this has to be like this because we have a 2-dimensional array, and we're gonna send the row pawn. So row pawn comma, remember our square class has 3 params: row, col, and piece. Then we're gonna send the column, and then we're gonna send a new piece. So we're gonna create a piece inside of the square class, but first we need to import it. So from piece import all. We need to import all because we want to have also oh, what happened? What? We want to have also the pawn, the knight, the bishop, the rook, the queen, and the king class. So we need to import all. So right here, we want to create a new pawn. Now, a pawn needs a color. Pretty simple. We're going to pass the color that we have here. And that's all. We have created all pawns. So I'm going to put a comment. These are all pawns. So pawns. Awesome. Now let's create the knights. This is gonna be even simpler than the pawns. So we're gonna have self.squares in row order. So knights are gonna be in the column 1 and 6. So actually, let me copy this. We're gonna have the squares on line 1 and 6 filled with knights. So go ahead and pass the same right here. We're gonna create a new knight, and we're gonna pass the color, and we want to copy this, paste it right here, and instead of 1 we want to have 6. So yeah, let me show you. Column 1 will be this one, so all these column, and column 6 will be 0, 1, 2, 3, 4, 5, 6, this one. So right here, there is where we want to have our knights. So okay, let's continue with our bishops, and I'm actually going to copy these. I'm gonna paste it right here, and bishops are gonna be on column 2 and column 5, I think. Yeah, 5. So change also here to 5, and we want to create a new bishop. There we go. Now let's go ahead and create the rooks, the queens, and the king. So let's see, right here, rooks. So self.squares in row order. Rooks are gonna be on the columns 0 and 7. I'm actually going to do this 0 and 7 right here, and we're gonna have a rook. We want to create a rook here. Now we want to have the queens. I'm sorry, the queen. Yeah, because we're just creating like one color, remember. So it's one queen and one king. So king, queen, and this the queen is going to be always on column 3, and this is gonna be a new queen, and the king is always on the column 4, and this is gonna be a new king. So we pretty much did this method. So we have it. I hope you understood what we did. It's actually not hard, but if you're a little bit confused, make sure to pause the video and try to, well, understand what we are doing. So okay, now we can call this method add pieces inside of our init method. So right here, after we create the board, we want to add the pieces. Now it receives a color as a parameter, so we're gonna add the white pieces, and then we want to add the black pieces, and we have it. We literally have it. Now we're missing the rendering part, so the same as we did with the background, we're gonna do with the pieces. So show pieces, we're gonna receive a surface, and that's it. I'm gonna pass it for now. So we're gonna do the following. We're gonna do these. We're gonna loop our board. So in order to loop our board, we want to do a double for loop, and inside of the double for loop, we want to check if there's a piece on that specific square. So we're gonna ask if self.board.squares on row comma call dot has piece. We're gonna create this method. We are going to do the following. Okay, we're having a problem. Oh yeah, we haven't created the self.board. So my bad. Right here on the init method, go ahead and type self.board equals to a new board, and it doesn't need params. We're gonna import it. So from board, import the class board, and we have it. We don't need params. So now it should, what happened? Oh yeah, I forgot the self param right here. So yeah, self.board.squares row comma call has piece. So let's go ahead and create that has piece method inside of our square class. So def has piece. It's gonna be pretty simple. We want to return self.piece different from none. So if we have a piece, this is going to return true. If the piece is none, so if the square doesn't have a piece, it's gonna return well, false. So let's go to our, where is it? Our game class. So if we have a piece, I wanna save into a variable called piece all these thing. So this dot piece. So instead of typing all these, we just type piece. Okay, so once we have the piece saved in a variable, we're gonna create an image variable, and this is going to be equal to piece dot, no, I'm sorry, to pygame dot image dot load the texture of our piece, so the piece dot texture. So remember our piece, so right here we have a texture. That texture is basically a path. So what we're doing right here, it's basically using pygame.image.load method to convert that texture into a, well, an actual image. So now that we have the image, we can create a new variable, which is image center, because we want to center our images on the board. And this is going to be equal to call times square size plus square size divided by 2. So this will center the image on the x-axis, comma row times square size plus the square size divided by 2. Now we can take our piece dot texture rect. So remember, let me show you, we have also an attribute here called texture rect. This is the rectangle of the actual image. So this is gonna be equal to the image that we created dot get rect So this is a Pygame method, because image is a Pygame image. And inside of the getRect, we're gonna put center equals image center. Now this way, we're actually centering the image. And then we wanna type the following: surface. So in this case, the screen, the surface that we are having as a parameter, dot bleed, and bleed receives the object that we want to bleed on screen. So in this case, the image, and the position. So that will be the piece dot texture rect. So yeah, I know this might be a little bit confusing, but let me explain. We are first checking if we have a piece on a specific square, right? We're then saving that piece into a variable. We're then taking the image, the actual image, not only the texture. So we're converting the piece that texture into an image. Then we're creating an image center. So this is responsible of centering our image. Then we're telling that the piece that texture rect is going to be the image that we created, but centered. And then we are actually telling Pygame, okay, bleed my image, the image that we created, inside the texture rect. And remember, texture rect already is centered. So I hope it is a little bit clear. Of course, you have Pygame documentation on Google if you wanna Google it, and you can make sure you understand this code. Now, once we have this, pretty simple, we just need to call it. So right here, after we show the background, we want to show the pieces on screen. And these, hopefully, it will start working. So I'm gonna save, run the file, and we have it, first try. Oh my god, we have it on the first try. We have our images being displayed on screen. So as you can see, they are centered on each square, and the position of the pieces is actually, well, correct. So yeah, pretty cool. I'm actually really happy it worked on the first try. So I know we did a lot of things, so make sure to pause the video and understand what is the square class doing, what is the board class doing, what is the piece class doing, all the piece classes, and finally, what are we doing inside of our show pieces. So yeah, pretty cool. Now we can continue with our game. So we're gonna continue with our dragger class. So the dragger class, it's basically responsible of letting us drag any of these pieces all around the board, right? So as you can see, we have just the images, but what we want to do is actually drag them. So let's start coding that. We're gonna start by adding some Pygame events. So right here inside the for loop, we're gonna start adding them. So I want you to think the following, and I'm actually going to run the file again. I want you to think the order of the events in order to drag a piece. So the first thing that happens, or the first event that happens, is the click, right? So if you want to drag a piece, you need to click on that specific piece, right? The second event is going to be the mouse motion. So when we are dragging the piece, we are targeting the event mouse motion. And the last event is actually undragging the piece, so releasing our click. So we're gonna code those three events and you'll see what I mean. So go ahead and type if event dot type equals Pygame dot mouse motion down. We want to do something. I'm gonna pass it for now. This is our click event. So click. Then we're gonna create the mouse motion. So elif event dot type equals Pygame dot mouse motion. We want to pass it for now, and this is going to be our mouse motion. And the last one is gonna be the elif event dot type equals Pygame dot mouse button up, and we're gonna pass it for now. So this is the click release. So we have our 3 events, and for the last event I'm gonna put an elif instead of an if. Okay, so we have our events. I'm actually going to put a comment right here. So this is quit the application. And we have our 3 events in order to drag a piece around. Okay, so we're gonna start with the click one. But before we start coding what happens when we click the screen, we wanna create our dragger class. So go ahead and type dragger, or go ahead and create a new file, dragger.py, and go ahead and create the class, the dragger class. So class dragger, we're gonna create the init method, and we're gonna leave it empty for now. And we're also going to import Pygame, and we're gonna import the constant. So from const import all. Okay, we're gonna leave it empty for now, but okay, what do we need to do? So the first thing is actually making a reference from our game. So self.dragger equals dragger. We need to import it. So from dragger import dragger. So we did the reference. So as you can see, game has a reference with dragger, and we are now going to make the reference here. So we're gonna create a variable called dragger, which is gonna be equal to self.game.dragger. Awesome. Okay, so the first thing that we want to do is actually the click event, right? So when we click, we want to save the position where we click it. So we're gonna be coding it, and I'm gonna explain in parallel what we are coding, because it's hard for me to explain like all the things we're gonna do previously. So let's start by creating 2 attributes, which we're gonna call mouse x, and this is going to be equal to none. I'm sorry, to 0, because there are gonna be integers or float numbers. And we want to create the mouse y. As I told you, I'm gonna be explaining this in parallel with the code that we're gonna do. And down here, we're gonna create a new method called update mouse. We're gonna receive self and a position as a parameter, and this is gonna be equal to self.mousex comma self.mousey equal position. So position is gonna be something like, let me see, it's gonna be a tuple like x coordinate comma y coordinate. So position is gonna be something like this, and we're gonna assign the mouse x to the x coordinate and the mouse y to the y coordinate. Pretty simple. Okay, so right here in the event, in the Pygame event inside, we wanna do the following. So we wanna take our dragger variable, and we want to put update mouse, and we want to send the event.position. So I'm going to actually print the event.pos for you to see what's this, but it's basically the position where we are clicking. So we have our board, and each time I click, you can see we have some positions. So we're sending this information to the update mouse, and we're storing that information inside of our mouse x and mouse y variables. Now the next thing we want to do is actually check if that position has a piece. So it's not the same. I want you to think it's not the same a position to a row. So let me explain. We're gonna create a clicked row, and that is gonna be equal to the dragger dot mouse x divided with double slash the square size. And we are going to have I'm sorry, this is mouse y, because rows are affected by the y coordinates. We're gonna create also the clicked call, and this is gonna be equal to dragger dot mouse x / square size. There we go. And now we want to check if our board, so we don't have a board. That's other thing we want to create right here. So board is equal to self.game.board. So if our board dot squares in the position click row, in the position click call dot has piece. So remember, this is a method that we already created, and this is from the square class has piece. So we're just asking if square has a piece. If clicked square has a piece. Okay, so if it has a piece, we want to do the following. But before we do that, I want you to see the difference between clicked row and mouse Y, and clicked call and mouse X. So right here, I'm gonna print. Let's see. I'm gonna print the dragger dot mouse Y, and I'm gonna also print the clicked row. And down here, I'm gonna print the dragger dot mouse X and clicked. This will be call. Yeah. So like this. And I'm gonna run the file for you to see the difference. So remember, these are our printing statements. I'm gonna click, let's see, I'm gonna click this one, the first square. So I click it, and as you can see, we get 51 0 and 50 0. So what's this? 51 is the dragger mouse Y, so it's the Y coordinate. 50 is the dragger mouse X, so we clicked in 50, 51, and these two zeros are actually clicked row and clicked column, respectively. So it's actually working because the rook is actually on the row number 0 on the column number 0. Now, if I click this one, as you can see, we click on 3,3. So it's actually correct because this square right here is located on the row number 3 and the column number 3. So it's actually working. I wanted to show you that because it's not the same coordinate to our row. So we want to do this conversion first. So I'm going to delete these print statements. And right here, inside the if statement, we want to create a variable called piece, and this is going to be equal to board.squares in the clicked row, then in the clicked call dot piece. So instead of typing all these, we are going to type just piece. Now we're going to create other methods inside of our dragger class. So we're going to have a method called saveInitial. We're going to receive self as parameter, and we're going to receive as a position also. We're going to pass it for now. And before we code that method, we want to create two attributes called initial row. And this is going to be equal to none, or actually 0 also. And self.initial call, which is going to be also equal to 0. And right here, we want to just, basically do the same conversion that we did here. So we want to save our initial row, and this is going to be equal to the position, the second element of that position tuple. So remember, a position is x coordinate, y coordinate. So we want to take the y coordinate. We want to divide it by the square size. So the same thing we did on our main class. And we want to have our self.initial call, and this is going to be equal to the position, the first element of the position array or the tuple, and we want to divide it by square size, and that's all. So same thing that we did here. And right here, we want to take our dragger, and we want to call that method, so it will be saveInitial, and we're gonna send the event.pos. Now it's important to do this inside the if statement, because we just want to do this if we're actually clicking a piece, right? Because if we click an empty square, we're not going to drag like an empty piece, you know? So, okay, we save the initial, and we also wanna save the piece that we are dragging. So inside of our dragger class, we're gonna create a new attribute, which is gonna be the piece, a piece attribute. This is gonna be equal to none as a default, and this is basically the piece that we are dragging. So we're gonna create a new method, which is gonna be drag piece, and we're gonna receive self and a piece as a parameter, and we want a self.piece. We want to basically set the piece equal to our new attribute. So we're basically saving, as we did right here, that we saved the coordinates. We want to save the piece that we are dragging, and we are going to have an attribute called dragging. This is going to be false as default, false, and right here we want to set the dragging to true. You'll see why we need this, but it's basically a boolean, so pretty simple. And we also want to have an undrag piece, so it's basically the same. We don't need any parameters because we just want to do self.piece equals none and self.dragging equals false. So these are the methods of our dragging class. We're missing one that we are going to code in a moment. So okay, let's see. We are saving our initial position, but we also need to save our piece. So dragger.drag piece, and we're gonna send the piece. Awesome. That's all what we want to do inside the click event for now. Okay, let's continue with the mouse motion. So inside the mouse motion event, we want to ask ourselves if we're actually dragging a piece. So if dragger.dragging, we want to do something. And that's why it's important to have this boolean attribute. Because, I mean, mouse motion is going to be targeted each time we move the mouse. But we just want to drag a piece if we're actually, well, dragging a piece. In other words, if we have saved previously a piece to drag. Okay, so I hope that's clear. So we're gonna create a new method, which is actually the one that's gonna be responsible of actually dragging the piece. So we're gonna call it update bleed. We're gonna receive self as a parameter, and we're gonna receive also a surface, and I'm gonna pass it for now. And inside of our mouse motion event, inside of the dragger.dragging, we wanna dragger.update bleed, and we're going to send our screen, and that's all. So let's go ahead and actually, well, code this method. So remember, on our piece class we have a set texture method which receives a size. So, and also remember that we have inside of our images folder, we have 80 pixels images, but also 128 pixels images. Why? Because when we are dragging a piece, I want that piece to be a little bit more bigger than the ones that are not being dragged. So the first thing we want to do is actually take our piece, so the dragging piece, remember, and we want to set the texture. We want to set the texture, but we want to send the size equals to 128. So that's the first thing we want to do. So texture, I'm gonna call it like that, texture. Then we want to create the image. So remember, this is just the path. This is the path to the image. But if we want to create the image, we want to do the following. So image equals pygame.image.load. So we need a path, and the path will be, well, the texture. So I'm actually doing a variable here, and it's gonna be self.piece.texture. So in other words, this is the path, but I call it texture, and we're gonna send the texture. So we have the texture and we have the image. The next thing that we want to do is actually the rectangle. So this is gonna be the image center, and if you see, this is actually the same thing that we did when we bleeded the pieces inside the show pieces. So we take the piece, we take the image, which is the piece that texture, which we take an image center, then we take the texture rect of that piece, and then we bleed it. So we're basically doing the same, but for our dragging piece. So the image center is gonna be the self.mousex and the self.mousey, because we wanna put our image where our mouse is actually located. Then we wanna set the piece. So the piece dot texture rect, and this is gonna be equal to the image dot get rect, and right here we want to put center equals image center. So I know it might be a little bit confusing, but it's basically, I'm actually going to copy it. I'm gonna show you. I'm gonna paste it right here. We're doing the same. So let me see. We have a piece. We have a piece. We have a piece. We have a texture. We have a texture right here. We have an image. We have an image. We have an image center. We have an image center. We have the piece texture rect. We have the piece texture rect. And the last thing that we're missing is actually bleeding the image. So it's pretty much the same. So right here, we're gonna put bleed. And it's basically going to be the surface.bleed. And bleed receives first the object that we want to bleed, so it will be image, and then the position, so it will be the self.texture rect. Self.piece.texture rect. So in other words, this method is updating the position, like the visual position of our piece, and that is gonna make the illusion that we are actually dragging that piece. We're also making that piece a little bit bigger, and you'll see why. It looks pretty cool. Okay, so we're actually done with this class. I told you it was gonna be not that hard. So I'm gonna put here draw methods or bleed method. And right here, I'm gonna put other methods, because I wanna divide the bleeding section from the other methods section. So right here, we did the same. I'm gonna put bleed methods. Okay, now let's go to our main class. We can finish our dragger from here. So the last thing we did was actually updating the bleed. So we also want to do the following. We want to actually, before updating the bleed, right, we want to also update the mouse position. So dragger.update mouse, okay, it needs a position, so we're gonna do basically the same thing we did here. Oh no, we can pass just event.pass. That's it. Why? Because we want to first update the mouse, obviously, and then we want to update the bleed, because this depends on the mouse position. If you see here, the update bleed depends on the mouse positions. So that's why we want to update our mouse first. Okay, so I think that's all for the mouse motion event, but we'll see. Okay, so we're gonna code the click release event, and I think we just need to call our dragger dot and drag piece. I think this should work. We'll see. But okay, let's go again through each line that we recently coded. So in the click event, we update the mouse, right? We then checked if the square that we clicked had a piece, and if it had a piece, we save the initial row and initial column of that piece that we are dragging. And this is because we need the save initial method, because In the case that we did a bad move, like an invalid move, we wanna return the piece to the initial position. That's why. And we also saved the piece that we're dragging into the variable dragger.piece. Inside the mouse motion, we checked if we are actually dragging a piece, and if that's true, we call the update mouse. So we are updating our mouse position, and then we are updating the bleed position. And finally, in the click release, we just undrag the piece. So pretty simple. I'm gonna see if it actually works. So we have our board. I'm gonna try to, I'm gonna try to drag this pawn. Okay, so we're dragging it, but we're having some bugs. Yeah, we're definitely having some bugs. So let's see what is happening. I'm gonna close it. Okay, so I'm actually going to run the file again to see what bugs are we having. Okay, the first one is that when we're dragging the piece, you can see it's not actually like fluid, it actually disappears. So we want to fix that, and we also want to fix this. Okay, so let's start with this one. Let's make our piece not disappear. And I think I know why. It's because we are, well, showing the background, then we're showing the pieces, but we're not like showing the drag piece. So the background is actually like bleeding on top of our drag piece. So I think that's the problem. So go ahead and type dragger.dragging. So if we're dragging a piece, we want to show it, right? So dragger.update bleed. And I think that should work. I'm not sure. Let's see. Okay, we're missing the surface, which is a screen. So it should work now. So let's drag a piece. Yeah, as you can see, it's working. Now we're having a problem. I don't know if you can see it, but behind our piece, it makes the illusion that there's another piece. So we need to fix that, and we also need to fix this. So the pieces that we start dragging first are not disappearing from their original position. So when I'm dragging a piece, we don't want that piece to be here. And also the texture is getting big. It's getting the texture of the 128 pixels. So we need to fix those things also. So let's start with the texture. That would be actually pretty simple. We need to go to our game class right here, and as you can see inside of our show pieces method, as you can see, we are bleeding all pieces, but we don't want it to be like this. We want to bleed all pieces except the one that we are dragging. So let me show you. I'm gonna put a comment here. So all pieces except dragger piece. So we have our object, remember, our self.dragger, and right here we want to check if piece, remember piece is the actual piece that we want to render. So if piece is not self.dragger.piece, we want to bleed that piece. So we're basically bleeding all pieces except for the one that we are dragging, right? So let's see if it actually works. So yeah, as you can see, we don't have, okay, we need to fix this, but let me show you again. We're fixing the issue that we had, that the piece stayed here, and that's well, we did it with that if statement that we recently coded. Okay, now we're having this problem. Let me show you again. When we undrag the piece stays with the 128 pixels dimensions. So we don't want that. So inside this method, we wanna first of all take the piece and set the texture to the size of 80 pixels. So remember, set texture is this method right here. Yeah, we don't have to send this param, because remember the param is by default 80 pixels, but I want to be explicit, so I want to send it. So yeah, we want to set the texture and then we want to bleed it. So let's see, it should work. So now when we undrag the piece, it should set the texture to the one of 80 pixels. So I'm gonna drag it, and as you can see, we did it. We fixed that bug. Now I wanna also fix this bug that we're having the illusion that we have another piece behind, and that is because I think it is because we are not showing the background when we are moving the piece. So before we update the bleed, we want to actually we want to call game.showBackground with the screen as a param. Okay, I think this should work. So let's see. Okay, we're having another bug now, but I think we fixed that one, right? Yeah, we fixed it. Now, I don't know what's happening. Okay, so we also need to draw, we also need to show the pieces. So show pieces. Show pieces in screen. I want to send the screen. And now we should have the dragging movement perfectly. Okay, it's working fine. So we can drag a white piece, we can undrag it, and it actually works. So try with any piece, it should work with any piece. Also with the black ones. Yep. So yeah, it's working correctly, we did it, and this is actually a big part of the code, because dragging a piece is actually pretty important for our game. If we cannot drag a piece, we cannot move it, you know? So we actually did a pretty big chunk of our game code. So yeah, pretty good. We did the dragging part and we're ready to continue. Okay, so the next thing we're gonna do is actually check all the valid moves that a specific piece has. So let's see. I'm gonna run the file again so we can drag our piece, but each time I drag a piece, I want the game to show me the possible moves. So for example, if I drag this knight, I want the game to show me that the possible moves will be, in this case, these two squares, right? If I drag, I don't know, maybe this pawn, I want the game to show me that the possible moves will be this and this one. So we're gonna do that right now. This is actually a complex method. We have to do a lot of things, but there's one method, the one that checks if it is a valid move, that will be quite complex, but I'm gonna try my best to explain it. So okay, we're gonna start by creating, let me show you the structure of our game, the class diagram. Inside of our board class, we have one method called calc moves. I told you this method was gonna be huge, and this is the method that we're gonna code next. Now calc moves is gonna be responsible, and this is inside the board class, so right here, calc moves is gonna be responsible of calculating the possible moves or the valid moves of a specific piece. So let's go ahead and create it. So go ahead and type dev calc moves, and we're gonna receive self as a parameter, we're gonna receive piece, we're gonna receive a row, and we're gonna receive a column. So let's see. I'm actually going to put a comment here because this is a big method. So I wanna actually describe what it does. So this is going to calculate all the possible or valid moves of a specific piece on a specific position. So this is what this method is going to do. Okay, so let's start coding it. Now, inside of this method, we're gonna have other methods. So the first thing we want to do is actually check what piece are we talking about. So we're gonna do some if statements. So if piece dot, we can do these two ways. So we can use the is instance piece from, for example, pawn, and this will make we will calculate all moves for any specific pawn piece, or we can do it this way, which is if piece dot name equals pawn. So it is the same, but I'm actually using the one of is instance. So if it's instance piece of pawn, so in other words, if the piece is an instance of the pawn class, we want to, I'm gonna pass it for now. Now, if the piece is instance of the knight class, we want to pass it also. I'm actually going to copy these for the bishop, for the rook, queen, and king. So bishop, we're gonna put bishop right here, then we're gonna put rook, then we want to put a queen, and then we want to put a king. Awesome. Okay, so we're gonna start with the pawns. You know, I'm actually going to start with the knights, because to calculate the pawn moves, it's actually harder than the knight moves. I want to give you an idea of what we're gonna do. So we're gonna start with something easy. The easiest one is the knight class. So we're gonna start with it, and then we're gonna do the pawn class, and the bishop one, the rook, the queen, and the king. So okay, let's start with the knight. So inside of our method, we're gonna create some other methods, as I told you. So there is gonna be one method called knight. Knight moves, and we're gonna pass it. We're not gonna receive any parameters, and inside of our if statement of the knight class if statement, we wanna call knight moves, which is a method inside the method. You'll see why. I mean, this is not necessarily, you can create these methods outside of the calc moves, but I mean, I want to have all the calculating moves inside of one method. So that's why I'm putting this method inside. So we've checked if the piece is actually a knight. We are going to do this method. So I want to start by creating a variable called possible moves. And this is going to be a list. I'm actually going to hit enter, and we're going to have this variable. It's actually an array. So I want you to think, and I'm actually going to run the file. I want you to think the possible moves that a knight has. So let's say this knight right here. It has two possible moves. This one, this square, and this one, right? But let's imagine we have a knight right here. And let's suppose there are no other pieces. Well, the possible moves of a knight are these ones. This square, this square, this square, this square right here, this square right here, this square right here, this square right here, and this square right here. So we have 8 possible moves for a knight that is at the center of the board, assuming that there are no more pieces. So that's the first thing we wanna have cleared. So let's go to our method. So let's think about it. So we know there are 8 possible moves. So I'm actually going to write a comment. So 8 possible moves, right? And we're going to represent a move with a tuple. So we can do this. I'm actually going to copy and paste 8 times. So let me see. Yeah, 8 times. So we have 8 possible moves. Okay, so we're gonna have a tuple. The first one is going to be, or the first possible move is gonna be the row -2 positions. So this will be going up 2 positions and going right 1 position. So I'm actually going to put them like this. So this is the first move. I'm gonna show just this one, and then I'm gonna do the rest. But this move, let's suppose we have a knight here, right here in this white square. We wanna the first move is going to be 2 rows going up from our original row, and one column going right from our original column. So let's go to our method. This is the first possible move. So we're gonna do that for the 8 possible moves. The second one will be row minus 1, comma col plus 2. Then we're gonna have a, let me think about it, row plus 1, comma col plus 2. If it's easier for you like to draw the possible moves on a paper, I actually recommend it, and it will make sense. The next one will be row plus 2. We want to go down, and we want to go to the left, to the right, I'm sorry. Then we want to have a row plus 2, comma column minus 1. Then we want to have a row plus 1, comma column minus 2. Then we want to have a row minus 1, column minus 2. And the last possible move is going to be a row minus 2 and column minus 1. So I think we have all possible moves there. Make sure you have all possible combinations. And as I told you, if it's easier for you to draw them on a paper, I actually recommend it because it will make much more sense. So, okay, now we have the possible moves. Then we want to check other things. We want to loop. So for possible move, we want to loop this array. So for possible moves for possible move in possible moves, right? We want to loop it. We want to then divide the row and the column. So we want to do something like possible move row. I know these names are quite long, but they will make more sense. Comma possible move col, and this is gonna be equal to possible move. Now we want to check the following. The first thing we want to check is actually if the possible move is actually on the range of the board, right? So for that, we are gonna create an static method, and I'm gonna explain what an static method is inside of our square class. So right here, go ahead and type at static method, and down we want to type def in range. We want to call it like this. Now in range is gonna receive a lot of arguments as a parameter. So I'm gonna pass it for now. I'm gonna explain it. So I'm gonna explain what an static method is in a moment. Now this asterisk followed by args is basically telling Python, or telling this method, okay, you can receive as many parameters as you want. So we need to loop these arguments. This is like a list of arguments. You can think it like that. And I'm actually going to first code the method, and then I'm gonna explain what a static method is. So we want to loop for argument in args. So we wanna loop our parameters, and we want to check if the argument is less than 0. So this is outside the board, or the argument is greater than 7. So this is outside the board also. If this is true, we want to return false. If not, we want to return true, but outside the for loop. So if we loop all and we didn't return false, we can return true. Okay, let's actually explain. Let me explain to you what an static method is. If you know already what an static method is, go ahead and skip this part. But let's say I create an instance of the square class. I'm gonna call it S. Now, with S, I can call hasPiece, right? The method hasPiece, as we know. Now, an static method is gonna let me call the method inside of that class without an object. I just need the class itself. So I can do something like square dot in range, and I can call this method without the need of creating an object. So I can put something, let me actually print, I'm gonna print square dot in range, and I'm going to pass, for example, 8, 2, 5, and 3. This is going to return false because of the 8. So I'm gonna run the file. Oh, okay. So I'm missing 2 params, but it was because of this. So I can delete it. I'm gonna run the file again, and as you can see, we get a false. Now, if I change this to 5, this will return true, as you can see. Now, I hope it's clear what an static method is. It's basically we can call the method with the class, not with an instance, right? So this, if I do this, I want to call the in range with an object. This is not going to be possible. Okay, so hope that's clear. Now, the method itself is telling us if all arguments are actually inside the board. So if there are less than 0, either if we have a row less than 0 or a column less than 0, we're outside the board. And if we have a row or column greater than 7, that also means that we are outside the board. So that's what this method does. So we can return to the board. And the first thing we want to do is check if, remember, we're going to use our class square.inRange. And we want to pass the possible move row and the possible move call to see if both of them are actually in range. Now, if they are in range, the next thing we want to check is if there is a piece, right? If there is a piece or the square is empty, right? So if it's in range, we know we're good to go, but we now need to check, in order to be a possible move, we need to check if the square is empty or if it has a rival piece to capture. So we're gonna create also a method right here inside the square class, and we're gonna create a method that I'm gonna name isEmpty or rival. I'm gonna receive self as a parameter. I'm gonna receive a color. You'll see why, and I'm gonna pass it for now. Okay. Inside of this, we're gonna call another method that we're gonna create right here, which is gonna be has rival piece. We're gonna receive self and we're gonna receive a color. We're gonna pass it for now. We are also going to create a new method, which is isEmpty. We're gonna receive self. This is going to return we're gonna return the self.hasPiece. Okay, so I'm sorry, this is not. So we want to return if the square that we are calling this method on has actually not a piece. So that will be that is empty, right? Okay, so isEmpty is ready. Now has rival piece. We're going to return the self.hasPiece. It has to have a piece, but also the piece, so the self.piece.color has to be different from our color, which is the parameter, right? So I hope it's clear. We're basically checking if it has a piece and also if the color of that specific piece is actually different to our color. So pretty good. Now I'm gonna create also another method. We're not gonna use it, I think, for now, but it's gonna be has team piece. So it's pretty much the same. So we're gonna put self and color. We're gonna receive self and color, and we want to do pretty much the same as we did here, but instead of not being equal to the color, we want it to be equal to the color. Okay. So those are the methods that we want to have inside the square class for now. Oh, okay. This method isEmpty or rival. We want to return self.isEmpty, or let me actually erase this, or self.hasRivalPiece. Has rival piece. Awesome. Now we need to send the color to the rival piece method. So we're gonna send them this color. Okay, awesome. Now we can go back to our board method, the night moves method. So we want to check if self.squares on the possible move row and then on the possible move call dot isEmpty or rival and we want to send the piece.color. Piece.color. So if this is true, we can continue. So let me explain. Piece is the piece that we are receiving as a parameter, and this is the piece that we want to calculate all the moves, right? So if it's empty or rival, is basically checking if that square of the possible move is actually empty, because that would be a valid move, or it has a rival piece, which is different from our piece.color. And if it has a rival piece, it will also be a valid move, right? So right here, we can actually, I'm going to put a comment, we're going to create a new move. So create a new move. And I'm going to pass it for now. Why? Because we need to create the move class. We haven't created the move class. So let me show you our structure. Right here, a move is made by an initial square and a final square. That's all. Move class, I'm sorry, it's actually pretty easy. So let's go ahead and quickly create it. So go ahead and create a move.py file. And we want to create the class move. We want to create the init method. I'm going to pass it for now. Okay, so as I told you, we want to receive an initial square and a final square, right? And right here, we want to put self.initial equals to initial and self.final equals to final. So let me actually put a comment here. Initial and final are squares. So they are not tuples, they are squares. That's something important to have clear. And that's actually pretty much all we have to do. So we're gonna go back to our board class. Right here, we want to create the new move. So we want to create the squares first. So the initial square is gonna be a square. And remember, a square has 3 params: row, column, and piece. So the row will be our row, not the possible moves row, because this is the ending row, right? This is the initial. This is the one that we're sending. So row and col. We don't have to pass a piece. And final square is gonna be also a square. But as I told you, is going to be with the possible move row, comma the possible move column. And for now, we need to do this, but for now we're not sending any piece. But I'm gonna actually put up a comment. Piece equals piece. You don't have to understand this. This is for me to remember that we have to do that. But for now, we're gonna leave it like this. It should work. And now we can create the move. So I'm gonna put a comment. Move. So actually this, I'm gonna call this create a new move. And this is create squares of the move, of the new move. So okay, move is gonna be move. It's gonna be a new move, which we have to import. So from move, import move down, and move receives an initial and a final. So we're gonna send the initial square and the final square. Awesome. And then we can call our piece.addMove method with the move. So I'm actually putting a comment here. So append new valid move. So as you know, we have inside of our piece class right here, we have a add moves. Oh, by the way, this should be add move. My bad. So add move, and we are appending to the moves array the new move. That's all. So let's go back here. So add move. Awesome. And that's pretty much all we need to do for the night moves. So yeah, I hope it's clear. We actually did a lot of things. We created an static method. We created all of these methods. The is empty, has rival piece. We created also a class, a new class. So we actually did a lot. So make sure this is clear. And yeah, you can pause the video if you like. Okay, so now we can continue with the pawn, the knight, the bishop, the rook, the queen, and the king I'm sorry, the knight, we already did it, but we can continue with the other ones. But first, I want to actually render the possible moves for you to see how is this method working, okay? So remember, we want to render, or the render methods are going to be inside of our game class, so bleed methods. So right here, I'm going to create a new method called show moves. And show moves receives self as a parameter and a surface, and that's it. We're gonna pass it for now. So we want to show the moves of the piece that it's being dragged, right? So we want to check if self.dragger.dragging. So if we are dragging a piece, we want to show the moves of that piece, right? So I'm gonna actually save into a variable called piece, and I'm gonna take the self.dragger piece. So this is the piece that we wanna show the moves, right? Now we wanna do the following. So for move in piece dot, I think we call it, I don't know if we call it valid moves or moves. I call it moves. So piece dot moves. We're gonna loop all the possible moves. So loop all valid moves, and we want to draw them, or we want to bleed them. So the first thing, we want to create a color in order to bleed it. Then we want to create a rect, and then we want to bleed it. So this is actually always the same, as you can see here. Let me show you. We create a color right here, then we created a rectangle, and then we bleed it. So same thing, we're gonna do the same. So let's start with the color. So color is gonna be equal. I'm gonna use the if statement in one line, but you can use the if statement, the normal if statement. So color is gonna be equal to C8646. This is a color, you'll see, 4. So 86 46 4. If the move dot final, remember we have a final attribute, final row plus move dot final call model 2. We're basically doing the same that we did here. We're getting the model of the row plus the column, because we want to draw light squares and dark squares depending on their position of the row and column. You'll see what I'm talking about. So model 2 equals 0, else we want to have the following color. So hashtag C8464 and 6. This is a red color. This one, I think this one's the light one, this one's the dark one. Yeah, this is the light one, this is the dark one. Again, I already told you this, but colors, we're gonna save colors inside of our theme class. But for now, I just want you to see what we are coding so we can hard code these values. Okay, let's now create the rectangle. This is gonna be pretty much the same as we did here. So remember, columns times square size, row times square size, and square size and square size. So we're gonna do pretty much the same. Move.final.call times square size. This is where we are starting on the x-axis. Then move.final.row times square size. This is where we're starting on the y-axis. Then the width and the height, so that would be square size comma square size. Pretty easy. Now let's go to the bleed part, which is actually pretty simple also. It will be just pygame.draw.rect, and it has some params, but we're gonna send a surface, a color, and a rectangle that we already created. So a color, I'm sorry, the first one is surface. Yeah, so surface will be screen. Surface, I'm sorry, we call it surface. Then the color, and then the rect. And we have it. We pretty much have the method which renders the possible moves of a specific piece. Now we need to call it inside of our main loop. So let's go to the main class. So we want to do the following. The first thing is when we click it. So when we click the specific piece, right? So right here, we wanna call our board.calcMoves, the method that we created inside the board class, this one. We wanna send a piece, a row, and a column. So we're gonna send the piece that we already created, right? We wanna send the clicked row and the clicked column, and that's all. So this method is going to calculate the moves of a specific piece. So we want to do the following. I'm going to put a comment here. I'm going to put show methods. And we want to first, well, we want to show the background, right? Then we want to show the pieces, game.show pieces. And then we want to show the, no, I'm sorry. The show pieces has to be the last method because we don't want the moves to be on top of the pieces. We want the pieces to be on top of the moves, of the possible moves. So we're gonna put here game.showMoves on screen. We need to do this also on top right here at the beginning of our main loop. So game.showMoves, and we wanna pass a screen as a parameter. Okay, what else? Let's see. So we already did the, when we click it, now we want to do when we move the mouse. So in here, we're already showing the background. So remember, in between the show background and show pieces, we want to show the moves on screen. What else? When we release it, we're gonna leave it like this for now. And I think this should work. Let me put a comment here. So I'm gonna put show methods also. Show methods. And right here also I'm gonna put something like show methods. So I think this should work. It will only work with our knights. So I'm gonna click, I don't know, this knight. Oh my god, it worked. So as you can see, yeah, we have it. We are displaying, we're showing the player what are the possible moves for the knights. Now obviously if you take a pawn, it will not do anything. If you take a queen, it will only work with the knights. So pretty cool. Let's now continue with the other pieces. Now before we do that, I'm actually going to create a knight. So let me run the file again. I'm actually going to create a knight on the center to make sure it's working with all the moves. So let's go. I'm gonna do this pretty quickly. I'm gonna go to the board. I'm gonna create a new knight. Let's see. I'm gonna create a new knight, and it's gonna be, I think 5,5 should be one of the center squares. So I'm gonna run the file to see. Okay, it's actually not. I think it's 0, 1, 2, 3, 4. It's actually 4. My bad. I'm gonna do this pretty quickly. So 4. This is just to check if the code that we did is actually working. So yeah, it's working. And I want you to see this. It's actually working on these two pieces because they are rival pieces. Now, if I put, I'm actually going to do this pretty quickly, I'm sorry. If I do this on the 3,3 square, I'm gonna run the file. As you can see, it actually don't works with these pieces because those pieces are of the same color as mine. So it's working perfectly. So yeah, pretty cool. I'm going to delete this line of code. That's it. Okay, awesome. We can continue with the other pieces. So we have the knight moves. Awesome, this is working. We can close this method. Now we're gonna go and create the pawn moves. So right here, go ahead and type def pawn moves. I'm gonna pass it for now. And I'm actually going to, okay, I'm gonna call it here first, pawn moves. but I want to do this in one line because I don't want to take so much space. I'm gonna pass this one for now, and I'm gonna pass the rook for now, the queen for now, and the king for now. Yeah, this looks much better, and yeah, awesome. Okay, let's go ahead and code the pawn moves method. So this is actually a lot harder than the knight moves. This is actually the hardest one of all the pieces. But okay, let's do it. Let's start coding this. So the first thing we want to check here is if a pawn has actually moved. So let me actually show you something. Right here. No, I'm sorry. Right here on the board class, inside the board class, we have a move method. This move method is gonna be responsible of setting the moved attribute of a piece, the Boolean attribute, to true. So each time we call the move method with a piece inside, we're gonna set this moved attribute to true. So the first thing we want to do is to check if the piece has moved. So if piece.moved, we want to do something, else we want to do something. Now I'm actually going to okay, I'm gonna code it first like this, and then I'm gonna pass it to a one-line if statement. We're gonna have a variable called steps. So right here, I'm gonna create steps, and this is gonna be equal. So if the piece has moved, the number of steps is gonna be equal to 1. Now, if the piece has not moved, the number of steps is gonna be equal to 2. Why? Because pawns on the first move, when they haven't moved, they can go to, well, they can advance 2 squares, right? So I'm gonna actually do the following: steps equals 1 if piece.moved, else 2. Awesome. I can delete this. We have it. So I'm actually going to put a comment here. This is going to be steps. And down here, we want to start checking the same things that we checked on the knight moves. So we're going to start by coding the vertical moves, because as you know, we also have diagonal moves when we want to eat a piece, right? This is only when we want to eat an enemy piece. Okay, so we're gonna start with the vertical moves. So I'm gonna code 3 lines of code that are gonna be quite confusing, and then I'm gonna explain them. So for now, let's save into a variable called start. We're gonna save row plus the piece dot direction. So remember, in this case, we are talking about pawns, and pawns, if we see inside of the class, they have an attribute called direction, right? So start is gonna be equal to row plus piece dot direction, or dir, and the end, something that we're gonna call end, is gonna be equal to the row plus the piece dot dir. This is actually inside brackets. So piece dot dir times 1 plus steps. I know this is confusing. I'm gonna explain it in a moment. Now we're gonna do a for loop, so it will be for move row, a variable that we're gonna call move row, in range. We're gonna pass start, then end, and then we want to put piece dot direction, and we want to pass it for now. Okay, let me explain. I'm gonna run the file, and I'm gonna have the code to my left, so right here. Okay, let's say we want to move this pawn, which hasn't moved. So okay, let's start with the start variable. Start variable is gonna be equal to row plus piece dot direction. So okay, the row is this one. This will be the 6th row plus the piece dot direction. We know that for white pawns, direction is -1, so we're gonna subtract 1, and this will give us a result of 5. We're in the 5th row right here. Now end is gonna be equal to the row, so this one, right? Remember, we're here, this is the start, and the end is going to be equal to row plus, let's do this operation. 1 plus steps first. This piece hasn't moved, so it has steps equal to 2. So 1 plus steps is going to give us 3. Now piece.dir is equal to -1. So -1 times 3 is going to give us -3, right? Now if we add this row with -3, it will give us right here. Right here is the end. So we have a start here in this dark square, and we have an end here in this dark square. Now, when we are looping, we are actually looping from here, from the start to the end, but it's exclusive. So we're gonna go up to here, right? And the step is gonna be piece.direction. Why? Because in the case of the white pieces, we're gonna start in the row 5th. We're gonna end on the row 3 exclusive. So we're actually ending here. So we wanna have a step of -1, and that will give us this result. So I hope this is clear. So we're basically going through each row which that pawn can move, right? Okay, let's suppose this pawn has already moved. The starting position will be here, and the ending position will be here, but as it's exclusive, it's gonna be here. So I hope that's clear. This is the logic behind the pawn moves. Okay, so we're gonna loop through each move row. Let's start doing that. So the first thing is to check if square dot in range of our actual move row. So move row, this is in range like this. So if it's in range, we want to check if that square is empty. Now, we don't want to check if the square is empty or rival, because we can only move vertical with the pawns if the square is empty, right? So we're gonna put if self.squares in the position move row, then in the position call, we're not changing of column, dot is empty. I don't know if we already coded that method. Let me see, in square is empty. Yeah, we have it. So if it's empty, we can create initial and final move squares, and then we want to create a new move. Okay, so initial position is going to be equal to a new square. We're gonna pass the move row, and we're gonna pass the column. So move row, comma call, and then this is actually initial. And then we're gonna create final, and this is a square. Oh, I'm sorry, this is move row. This one is just row. Remember, row and call are the initial ones. This is the final one, the move row, comma call. Call is not gonna change. Okay, now we can create a move. So move equals new move with the initial and final. Awesome. And lastly, we can piece dot add move move. Awesome. So same thing we did with the knight, actually, right here. The difficult part about this method is actually understanding this logic. So I strongly recommend you to pause the video, actually take a piece of paper, that helps me a lot, and actually try to write these things with numbers, and you'll see it makes sense. Okay, now what happens if the square is not empty? We want to break the loop. We want to break it. Why? Because if the first square is not empty, we cannot like make possible the other square, even though it's empty, because we are already blocked. Okay, so this means, so actually I'm gonna put a comment. This means we're blocked. And same logic with the first if statement. If we are not in range for our first square, we're not gonna be in range for our second square. So this is not in range. And we want to break. We want to break the loop. Awesome. So I think we have it. I'm actually going to put these breaks here. Awesome. We have the vertical moves. So as I told you, try to understand these first 3 lines of code. Those are the hard things of this method. Okay. Let's see if it actually works. So I'm gonna go to the main, and it actually works, as you can see. Awesome. So I'm gonna try it with all pawns. First the white. So they work. Now the black ones, and as you can see, they also work. Awesome. Now I'm gonna, let's see, I'm gonna create, I'm gonna run the file again. I'm gonna create a pawn, a black pawn, right here, actually right here. So in the row number 0, 1, 2, 3, 4, 4, 0. So in 4, 0, I'm gonna create a pawn, a black pawn. So let's go to board. This is for testing. Right here, I'm gonna copy these 4, 0 to test it. So self.squares 4, column 0, 4, and 0. Okay. When I run the file, we should have a pawn right here. Oh, I'm gonna run the main file. So yeah, we have a pawn right here. So now, if I click this pawn, we should have just this square as a valid move. Awesome, it's working. Okay, now I'm gonna increment the row. So let me increment the row. So this 4, I'm gonna make it 5. And now we should not have any possible move. So as you can see, we don't have possible moves. This is actually working. Awesome. So I'm gonna delete this. This is for testing, remember. And now we can go ahead and code the diagonal moves. So right here. So we're gonna create a variable called move row. And this is gonna be equal to row plus the piece.dir. So remember, this is the same as the start here. This is giving us the start of the moving row, the possible move row. I'm actually going to call this possible to be explicit. Oh, we call it, I'm actually going to change the name to possible move row. I want to be explicit. So right here, I want to put possible move row. And we're going to have a possible move with calls. We want to have an array. So we're going to have two possible move calls. The first one is going to be call -1, so to the left. And the other one is going to be called +1, so to the right, okay? That's why it's diagonal. Now we want to loop these possible move calls. So for possible move call, impossible move calls, we want to, as always, we want to check if the square dot in range, and this is without space, so like this. We want to check the possible move row and the possible move call. So if those possible move coordinates are in range, we want to now check if the self.squares in the position possible move row and then possible move call dot has rival piece. I don't know if we created this method inside the square class. Has rival piece. Yeah, we did it. So we want to send our piece.color. I'm actually going to change this for enemy. It's actually more clear. So let's quickly do that. So instead of rival, we want to put enemy. And we want to change also inside the board class, instead of rival, so rival, I'm gonna command D. With command D you can search all the rival things, the rival words. So I'm gonna put enemy. So we're changing also the knight moves. Okay, I just changed the name. You didn't have to do that. But okay. So if it has an enemy piece, we can actually move, right? Because we cannot move if the diagonal is empty or if it has a piece of the same color as ours. So if it has a rival, an enemy piece, I'm sorry, we can actually create a new move. So we're gonna copy these comments. I'm gonna copy these two comments. And we can create initial and final move squares. So this will be initial. This is gonna be square from row comma call. So this is the initial position, and the final one is gonna be a new square. And we have the possible move row, comma, possible move call, and that's it. Then we want to create the move. So this is a move, a new move with initial and final, and then we want to append it. So this is another comment actually, append new move. So right here, append new move. And this is gonna be piece.addMove. Awesome. So yeah, we're pretty much doing the same lines of code. We actually can create a method for this, but maybe at the end of the video we can do that. For now, this is working correct, so we're gonna leave it like this. Now let's see if it actually works. I'm gonna explain it pretty quickly. What we did was, so we get the possible move row. If we're gonna move diagonal, we just move by one step, so we don't need steps here. So it will be our initial row plus the direction, so +1 or -1 depending on the color. Then we create the possible move calls, which are call -1 to the left or call +1 to the right. Then we loop this list, and we're basically checking if that's a possible move with the possible move row and the possible move call. So for each possible move call. Okay, hope that's clear. I told you it was gonna be a little bit more harder than the knight moves. But yeah, let's test it. So we need to create some pawns. Let's create some black pawns. So the first one is gonna be, let's see, the position. I think it was row 5. Yeah, it was row 5. Column is gonna be 0. There we go. And let's create, I think we can create just one to test it. So let's see, I want to run the file. We should have a pawn right here. So the possible moves here will be this square, right? And it's working. Awesome. I'm gonna move this pawn right here to see if it works both directions. So I'm going to put these to 1, the first column, or the column with index number 1. Okay, awesome, it's working. Pretty cool, it's working. So when we code the move method, this is gonna be a valid move. All the red squares are valid moves, so we could eat this pawn right here. Awesome. We have the pawn logic, the pawn moves logic. We're missing also some things of the pawns. We're missing the promotion of the pawns, but that will be in a different method. So as you know, if you reach the final row, so if I reach here, I can make that pawn to be a queen, a new queen. We're gonna do that later. And we're also missing something called ampersand. I don't know if we are gonna code ampersand, but we're missing that. So I'm actually going to put a comment. Oh no, you know what? Instead of a comment, I'm actually going to use this thing that I have here. I'm gonna create some to-dos. So I'm gonna create first the pawn promotion. So we need to do this. And we are also going to do the pawn ampersand. This is for me to, well, not forget that we have to do that. So yeah, pretty cool. So yeah, we have the pawn moves for now. we can close this method, we can close the knight moves method, and we can continue with the bishop, the rook, and the queen. These methods, or well, these pieces are gonna use the same method. So we're gonna create a new method called straight line moves. We're gonna pass it for now, and we're gonna receive something called incrs, which stands for increments. You'll see what I'm talking about. So in these three cases, bishop case, rook case, and queen case, we're gonna call the straight line moves, but we're gonna pass different increments. I'm actually going to hit enter here. It's actually more clear. Yeah. Okay. Why? Because bishops move in straight line, rooks move in straight line, and the queens move in straight line. The only thing are the increments. The only thing that change are the increments. We'll see what an increment is. So, let's start with the bishop one. The bishop increments. I'm gonna hit enter here. The bishop increments. So I'm gonna run the file for you to know what I mean with increments. So let's take this bishop. Okay, yeah. Let me actually comment these. I'm gonna comment this. Comment that for now. I'm gonna go to my main class, run the file. So let's say we have this bishop, or any bishop. Increments, what I mean with increments is how are you gonna move in a straight line. So for this bishop, or for any bishop I mean, increments will be either this diagonal, and this is row -1, but also call +1, row -1, call +1, row -1, call +1. So as you can see, that is what I mean with increments. The increments in that case will be row -1 and call +1. But we can also move in this direction. So we can move in the direction of row -1, but call -1. But we also move in that direction, like downwards. So let's suppose we are in here, we can move downwards. So that will be row +1, column +1, or we can move row +1, column -1. So those are increments. In the case of the rooks, an increment is, well, basically row -1, and we don't even care about the column in this case. So just row -1, or just call +1, or just row +1, or just column -1. So those are the increments. Now the queen, it's actually not hard to code the queen, because it's the combination of the bishop and the rook. That's a queen. So pretty simple. We're gonna code first the increments, or the logic behind, let me go to the board class, the logic behind the bishop and the rook, and then the logic behind the queen will be basically the combination of these two classes. So I know it might be confusing. Let's start coding. It might help you understand clearly what we want to do. So okay, let's start with the increments of the bishop. So increments of the bishop, this is going to be a list, by the way. So there are going to be the following. There are going to be tuples, and the first one is going to be let's see, -1 for the row, comma, +1 for the column. So this is a going to the upper right diagonal. Yeah, so upper right. I'm actually going to put a comment. Up right. We also have the increment going down right. So that will be 1, comma. I'm actually going to start with the other one. So -1, -1. And this is the up left corner. Then we have the 1, comma 1. And this is gonna be an increment for the down right. I hope this is making sense. And the last one should be going down left. So that is 1 for the row, and -1 for the left. So down left So these are the increments for the bishop. We're gonna do the increments for the rook. So it's gonna be -1, 0, 0. This is up basically. Then we have the 1, 0. I'm sorry, the 0, 1. This is left. I'm gonna go clockwise. This actually doesn't matter the order you put this, but I'm gonna go clockwise. So left. Now I'm gonna go down. That will be -1. I'm sorry, 1, because we're going down. 1, 0. This is down. And the last one is gonna be to the left. So we have the -1, 0. I'm sorry, 0, -1. It's a little bit confusing, I know. Left. So yeah, we have the rook increments and we have the bishop increments. Now, as I told you, queen increments, pretty simple. Just copy, let's see, we're gonna copy, just copy all the bishop ones and let's copy all the rook ones, and that's a queen. And that's it. And this is pretty cool. This method is pretty cool because once we code this method, we're gonna be able to move the bishop, the rook, and the queen. We're gonna kill 3 birds with 1 shot. So yeah, pretty cool. Let's see. Okay, let's start coding actually the straight line moves method. Okay, so we're gonna start by looping. So for inc in incs, so for increment in increments, we're gonna create something called row inc, comma call inc. This is gonna be equal to the inc, so to the increment. It's funny how I say inc. What else? We're gonna create, as always, our possible move row, and this is gonna be equal to the row plus row increment. Now, by the way, if you have another way to check the possible moves of the bishop, the rook, and the queen, go ahead and do it. You don't have to follow this, because this was my logic to solve that problem, right? And I know it might be a little bit hard to understand someone else's code. So yeah, make sure to think about it, and if you want to try it, well, go ahead and create your own method. So okay, I'm gonna do the same with the possible move call. It's gonna be equal to the call plus the plus the call increment. Now we can start checking. So we're gonna check. I'm gonna put a comment here of while true. I'm gonna just comment this. Just comment this. You don't have to understand it. I'm gonna go to this once we code this part of the code. So okay, we're gonna have, or we want to check if the square, as always, dot in range, and we're gonna send the possible move row and the possible move call. So if they are in range, we want to check also if the square dot, oh, I'm sorry, we need the self dot squares, we need the instance here, so squares in the possible move row and possible move call dot is empty. We want to do something. I'm gonna pass it for now, so empty. For this case, and you'll see why. I know this is confusing, but just let me, we'll code it first, and then we're gonna try to understand it. So we want to divide the empty and the other one though has enemy piece. Why? Because if the square is empty, we want to continue checking the increments. But if it has an enemy piece, well, we're gonna add that to our move, but we then want to break this while true that I'm commenting for now. So hope that's clear. But right here, we want to check also if the self.squares in possible move row, possible move call dot has enemy piece. And we want to send the piece.color. We want to pass it for now. Now, if it's empty, we want to create a new move, right? Create new move. But if it has an enemy piece, we also want to create a new move. So I'm just putting the comment, create a new move. Now, if we are going to create a new move on both if statements, we can do it outside. So right here. So we're gonna create the variable initial. I'm actually going to copy the comments right here. So create squares of the possible, because this is possible new move. So initial is going to be equal to a new square on the row and column. Final is going to be equal to the square but in possible move row and the possible move call. And the actual move, so create a possible new move. This is gonna be equal to a new move, initial and final. Awesome. Now here we don't want to create it, we want to append it. So append new move. Also here, append new move. So if it's empty, we want to have our piece.addMove move. And if it has an enemy piece, we want to do the piece.addMove move, but then we wanna, oh, okay. We're gonna leave it like this. Now, I wanna go to this, to the while true. So as you can see, we're doing this for each increment, but what we wanna do, I'm actually going to run the file for you to see. So let's say we have this bishop. We're doing it for each increment, but we wanna continue doing it. You know, like all the straight line of that increments, then all the straight line of the other increments, so these ones, then the other ones, so the down left, and then the other ones, the down right here and the down left here. So we want to like continue doing it until, when I run the file again, what happened? Oh my god. Oh, so right here, I'm gonna put the board class. So I wanna continue doing it until we reach either a piece. So this will be an immediate break of the while true, or we have an enemy piece. So let's suppose I have this bishop here. So I'm gonna increment. This is valid, increment, this is valid because it's empty, this is valid because it's empty, but then this is also valid because, well, it has an enemy piece, but I want to break. I want to break the code right here because I don't want to continue, right? So hope that's clear, and that's why we need a while true. So while true, and we're going to put all these inside the while true. So while true, we're going to do this. And at the end of the while true, we want to change the increments. So we're going to do something like move row. Actually, possible move row, comma, possible move call. It's going to be equal to the possible move row plus the row increment, and then comma, the possible move call plus the call increment. The call increment. I'm actually going to do this in 2 lines of code. So I'm actually going to copy these. So the possible move row is going to be equal to this, and then the possible move call is going to be equal to this. Yep. So this has to be outside, so right here, like inside the while loop, but outside this if statement. Now, let's start, we're missing some things. So I'm going to put a comment here. First, these are increments. We're incrementing the increments. It sounds funny, but it's what we are doing. So incrementing inks or increments. Yeah. Okay, let's see. As I told you, if we're not in range, so we're going to put a else here. We want to break. So that's obvious. If we are not in range, we want to break it immediately. Break. Not in range. Now, if it's empty, we can continue. So empty equals continue looping. Why? Because at one point we're gonna be here, not in range, or at one point we're gonna be here, enemy piece, right? Okay, so we don't have to do anything here, but if it has an enemy piece, we want to actually add the move first, but then we want to break it. And this is the example that I show you here. So let me show you again. Let's suppose we have a bishop here. Oh my god, it's actually, well, it's not working, but we're actually getting the squares. Okay, this is funny because I wasn't expecting this to work, but okay. We have the bishop here. Let's suppose we have it here. When we reach this point, so this enemy piece, this is valid move. This square is a valid move, but we want to break it because we don't want to continue, right? So yeah, pretty funny. It's working. We're missing one if statement, which is our own piece. So has team piece. So I'm actually going to copy all these. I'll paste it here. So we're gonna put it has team piece. I don't know if we send a param for that. Yeah, we send it. Let's go to the board. So piece.color. We don't want to append that as a move. We just want to break it. So has team piece equals break. And this is gonna be equals add move plus break. So hope that's clear, and I think this should work. This should work. So yeah, awesome. Bishops are not working, obviously. The tube is not callable. What happened? Okay, we're gonna see that bug in a moment, but let's create a bishop. Let's create a bishop to test our increments on the bishop. So we're gonna do it on the row. I'm gonna put it 5 here. 5. And the column, let's see, I'm gonna do it actually on the 7th, maybe. So yeah. Okay, so we create a bishop here. If you're asking yourself, why is it creating only black pieces? It's because we're calling the add pieces with the black param after we call the add pieces with the white param. That's why we only see the black pieces. So it's actually working. As you can see, this is what I meant. So if it's empty, just continue incrementing. Now, if it's your team piece, break immediately, break it. But if it's the enemy piece, okay, you can add it, but then you need to break it. So I think it's working. Let's put it on the center just to see. So 5, let's put 4,4. Let's put a 4,4. If it works with black, it should work with white. I'm not gonna test it, but it should work. Okay, awesome. It's working pretty good. Now, we had a problem when we tested the queen one, but we'll see. Okay, I'm gonna delete this line of code. What else? Okay, we're calling the straight line moves with the bishop. Let's see if this is correct. -1 0. This is going up. Yep. This is going left. Yep. This is going down. Yep. Left. Yep. I mean, this is right. My bad. Okay, so something was happening. Let's check the rooks. Okay, we're having a problem here. So we're not having problems with bishops. Let me actually grab or drag bishops. Yeah, we're not having problems. But we are having problems with the rooks and queens. Okay. Let's see. Type error. Straight line moves takes 1 position, but 4 were given. Okay, what's that? Oh, okay. This error is because we didn't put the increments inside the list. So let's see if it actually works now. So we have a comment here. Perhaps you miss a comma. It's not callable. Okay, we'll see what's that. Okay, we can drag the rooks. We're gonna test it in a moment. But when I want to drag a queen, something is happening. So it says tuple object is not callable. So it should be something. It should be an error here. Yeah, I was missing a comma. Yeah, that was the error. That was the error. Okay, now it should work also with the queens. Yeah, nice. Okay, we're not having problems. Let's test it. I'm gonna put both a queen and a rook on the middle of the board. So let's do the rook here. It's gonna be on 4,4. And we're gonna have a queen on D. Let's do 3,3. Let's see. Okay, I'm gonna run the file. Let's hope this works, because this is a lot of code and it's pretty good if it works first try. So it's working. I think it's working. Yeah, okay, let's see. The queen can move diagonal. It breaks here. It breaks automatically here because we have our piece. It breaks here. Awesome. So diagonals are working perfectly. Now horizontal moves, they are working also. It breaks when it touches an enemy piece. Awesome. It works. So now we should see the rook also working. Yeah, it's working. Okay, nice. We have it. We have the visual valid moves coded. We have a pretty good chunk of our code. Awesome. We can actually close straight line moves. So as I told you, we kill 3 birds in one shot. The bishop one, the rook one, and the queen one are ready to go. We're missing king and we're done. So let's start coding our king moves. So I'm gonna create a new method inside of our calc moves method. I told you this method, it's probably the biggest method we're gonna code. So if we are able to code this, we're able to code anything. So we're gonna create a new method, king moves. We're not gonna receive any params and we're gonna pass it for now. Okay, I'm not gonna code the castling. So for those of you who don't know what castling is, it's basically when you have, let's suppose this bishop and this knight are not here. So we have an empty connection between the king and the rook. And this could be also with the other rook. But I'm gonna make the example with this. Castling will be to move the rook here and then the king here. And you can do that in one move. As long as you haven't moved before your king or your rook. So that's castling. Now castling is gonna be part of the king moves, but I think we're not gonna code it yet. So I'm gonna actually add it to the to-dos. King castling. And we wanna code 2 castlings. The king castling and the queen castling. There are 2 castlings. So we're gonna leave that on the to-dos. Okay, we're just going to code the moves, the normal moves of the king, which is actually easy. So we're gonna create a new variable. We're gonna call it adjacents. So like this, and we're gonna do pretty much the same as we did with the knight moves. If you remember, we just put all the possible moves and then we check for those possible moves which of those were valid. So we're gonna do pretty much the same, but with the king possible moves. So king possible moves are the following, are basically the adjacent squares. So this one, this one, this one, this one, this one, the one downwards, the one downwards here, and the one downwards here. So all the adjacent squares. So that's gonna be pretty easy. We have a total of 8 possible moves. So let's start with the adjacent, which is up. So we row -1. and 0. Now it's not 0, but call plus 0, because these are not increments, so it's different. This is up. I'm gonna put a comment here, so up. Then we have the one to the upright, so that will be row minus 1, call plus 1, comma, and this is up right. Then we're gonna have to the right, that is gonna be equal to row plus 0, comma, call plus 1, comma, this is right. I'm gonna put some spaces here. Then we have the, let me think, that will be down right, so that will be row plus 1, comma, call plus 1, comma, and this is down right. Then we have down. I'm going clockwise, so this will be row plus 1 and call plus 0. This is down. Then we have down left, so it will be row plus 1, comma, call minus 1. So this is down left. Then we're gonna have left, so this is row plus 0, call minus 1. So this is the left one. And then we have the up left, so that will be row minus 1, minus 1, comma, column minus 1. So I think that's correct. And we have the what was this? It was up left. So yeah, I think we have the 8 possible moves. Yeah, okay, awesome. And we're going to do basically the same thing we did with the knight moves. So we're gonna loop and we're gonna check, and that's all. We did it. So let's start the loop. So for edge, this is adjacent, in adjacents, or actually possible move. I'll call it possible move. For possible move in adjacents, we're gonna have the possible as always. This is repetition of code. Possible move row, comma, possible move call. This is gonna be equal to the possible move, and we want to start checking. Okay, so if, as always, this is always the same, in range, and we want to send the possible move row and the possible move call. Now if it's in range, we want to check if it's empty or enemy piece. So if the self dot squares on the position possible move row on the position possible move call dot has is empty or enemy piece dot color, we wanna add our comments. So I'm actually going to copy these. I think it's gonna be the same. We can actually create, as I told you, we can actually create a method for these because we're doing the same things. I think we can actually merge king moves and knight moves, but we're gonna do that later if it's necessary, because we're repeating a lot of code. But I think it's clear for you to understand it this way. So okay, create squares of the new move. Initial is gonna be square row and call. Final is gonna be square of possible move row, possible move call. Oh yeah, we have these, which I commented on the knight moves. Yeah, we need to do this later also. I'm gonna come back to these later. And then we want to create the new move, and then we want to append it, and that's all. So I want to actually put a comment here. These are the normal moves, because we can also have the castling moves, and inside the castling moves we can have queen castling and king castling. We're gonna come back to this later, but for now I think the king should work. So I'm gonna close it. and I'm gonna call it here. So king moves. That's it. Let's try it. I'm actually, because I mean the kings are not able to move on the first move, so obviously we can't test it. So I'm going to create a new king. Let's put it on the, let's see. I'm gonna put it on the row number 5 and the column number, I don't know, maybe 3. And this should work. Yeah, we have a king right here. So the possible moves are basically all adjacent. Awesome. Yeah, because we can eat these pieces. But we can also move to empty squares. Now, let's see. I'm gonna try to put it on the row number. Let's see. I think it's row number 2. So I'm gonna test it with this row. Okay, now valid moves should only be these ones. Now these 3 are not valid moves. Awesome, we have it. So happy, we have it. Oh my god. So we actually have the biggest method of all the game. Can you believe it? Pretty cool. We have it. Calc moves is ready. So yeah, we have some to-dos. We have the pawn promotion, pawn en passant, and the king castling. We're gonna come back to those later. But for now, we have the moves, the visual moves. We're gonna go ahead and code the console moves. So we're literally moving the piece on our console board, okay? That's our next step. Okay, so this is gonna be actually much easier than drawing the moves, because we already did the logic. If you think about it, we already did the part where we get all the valid moves of a specific piece. So this part is actually not hard. So let's go ahead and create a new method. It's gonna be move. We're gonna receive self as parameter. We're gonna receive a piece, and we're gonna receive a move. We're gonna pass it for now. What else? I'm gonna create another method called valid move. So valid move, it's gonna receive self as parameter. It's gonna receive a piece, and it's gonna receive a move also. This is pretty simple. We can just code it now. We're gonna return move in in piece.moves. That's all. Pretty simple method. Okay, now we're gonna code the move one, which is actually not hard. So yeah, let's code it. So we're gonna have an initial position. This is gonna be equal to the move.initial, and we have the final, which is move.final. Now I'm gonna put a comment here. So we're gonna put console board move update. So we're gonna update the board, the console board, as I told you. So we're gonna get the squares, self.squares in the position initial.row, and in the position initial.column, initial.col. So this is basically the square. In other words, this is the square where our piece is located at this point of the code of the game. So we're gonna set this equal to none. I'm sorry, not this, but the piece. So the piece in here is gonna be equal to none, because we don't want to have the piece on the initial square. We want to have it on the final one. So we're gonna put it equal to none. Now we want to do the same with the final. So self.squares, and instead of initial, we're gonna put final. But in this case, the piece is gonna be equal to piece, and that's all. So pretty simple. Also, as I told you, inside of this method, we need to move, like virtually move the piece. So we're gonna put like piece.moved equal true. So remember, we use this attribute for the pawn moves right here. So it's actually important. Then we're gonna like clear valid moves. Why? Because we change position, so we need to clear. So it will be piece.moves. It's gonna be equal to this. We're gonna actually create a method right here. So def clear moves, self as a parameter, and it will be self.moves equal to an empty array, and we're gonna call it so clear moves. Clear moves. There we go. So we clear the valid moves because yeah, we're changing position. And the last thing we're gonna do is we want to create a new attribute. So actually, let's go to our init method. We're gonna create a new attribute and we're gonna call it last move. You'll see why. And this is gonna be equal to none as default value. But here, last move is gonna be equal to the move. Where is it? To this one. So set last move. So each time we move a piece, we want to like render the move. So yeah, we're gonna save that, and I think we're done. So pretty simple method. As I told you, this was the method, the hard method, the complex method, because it has 5 big methods inside. So it's actually huge. This method is huge. So okay, we have the move thing ready. Now we need to connect the move with the actual game. Not with the actual game, but with the main class. So let's see, what do we have to do in order for this to work? So let's think about it. We want to make a move when we undrag a piece, right? When we have the click release. So right here, we want to do the following. So this is the last line of code that we want to have inside the event statement, if statement. Because yeah, we want to drag it at the end. So right here, we want to do an if statement. So if dragger.dragging, if we're actually dragging a piece, it means that if we made a click release, we did a move, or we wanted to do a move. So the first thing we want to do is actually take our dragger. We want to update the dragger.update mouse with the event position, and then that we have updated the mouse of the dragger, well, the mouse position of the dragger, we want to do the following. We want to create 2 variables, released row, which is going to be equal to dragger.mousex, mouse y, this is mouse y, divided by square size. We already did this. This is the conversion between the position and the rows, or well, the board position. So released call is going to be equal to dragger.mousex / square size. We have it. Now we want to check if it's valid, if that move is valid, right? So we want to create it. So create move, possible move, because we don't know if it's valid, remember. So we're gonna do initial, as always. It's gonna be a new square, and it will be dragger.initial row. Initial row. That's why we have those attributes, and we have dragger.initial call. Okay, square is not defined. We need to import it. So from square, import square. We have a final, which is equal to square released row and released call, right? And we have a move, which is a new move. We need to import move class, initial comma final. So also from move, import move. Okay, now that we have the move, we can actually make or call, we can call this valid move method. So if board dot valid move, no, validate. Did I call it validate? No, it's valid move. So valid move. So it asks for a piece. So it will be the dragger dot piece, and it asks for a move. So right here we're asking if this is a valid move, and if it is, we want to call our board.move method with the dragger.piece, comma, it asks for a move. So we're gonna send the move. So this is going to move the piece inside the console board. And why do we need that? Because the game.showPieces is actually accessing to the console board. That's why. You'll see why. You'll see what I'm talking about in a moment. Once we move it, we want to draw. So draw or show methods. Show methods. So we want to show the background on screen. We want, I think we don't need to show the, we don't need to update the bleed. So the dragging piece, and we also don't need to show the possible moves, obviously, because we already released it. So game.show pieces, that's actually important. Screen. If you don't show the pieces after you show the background, pieces are gonna disappear. So yeah, I think we have it, because yeah, we make a move only when we make a click release. Yeah, I think we don't need to edit click or mouse motion, because we're calculating the moves inside the click event, and that's it. So yeah, I think this should work. So I'm gonna run the file, and we should see the following. We should see, oh, by the way, I'm gonna we have a king here, so I'm gonna actually delete it. Add pieces right here. Okay, so we should see the following. When I move a piece, so let's say if I move this pawn right here, we should see the pawn here, we should see this square empty, and that's it. So I'm gonna try it. It doesn't work. I don't know why. Oh my god, I don't know why. It doesn't work with any piece. Why is that? Okay, we need to fix something. So let's start debugging. We should enter here, so I'm gonna print valid move. So we should see printed a valid move on console. No, we don't see it. Why is that? Okay, so we're not entering this if statement, board valid move. So let's check this method. Return move in piece.moves. So yeah, this method is correct. Let's see the move one. We are taking initial, but we haven't moved. Yeah, so this method shouldn't be the problem. I don't know what's the problem actually. Okay, I'm gonna do the following. I'm gonna try to debug it myself, and once I have it, I'm gonna tell you what's the problem. Okay guys, so I know the error. It was actually hard to find, and I'm gonna show you how to fix it. Okay, so what's happening? I wanna explain what's happening. So let's go to our board class. Right here, we're returning if a move is in the piece that moves. So what's Python doing behind the scenes here? It's actually looping, right, through each piece moves, and it's comparing the move to each of the piece valid moves, right? And in case the equality is actually true, he's gonna return true. That's what Python is doing behind the scenes. Now the problem is the following. Python doesn't know how to compare a move to another move, because this is a self-made object, like we did moves. So Python needs to know somehow if this move is actually equal to another move. So we need to tell him what's Like, what's the condition for a move to be equal to another one? So we're gonna do that. So that's the problem. Now the solution is the following. It's pretty simple. So we're gonna create another dunder method, and dunder methods are just special methods that Python has. So we are gonna create the dunder method EQ, which stands for equality, and we're gonna type this. So we're gonna receive self and other as a parameter. I'm gonna explain you why. So what we're gonna do here, we're gonna tell Python when does a move is actually equal to another move. So that's what we're gonna do. So we want to return if the self dot initial, so if the initial square is equal to the other dot initial square, and the self dot final square is actually equal to the other dot final square. Now we have a problem. Python doesn't know when a square is actually equal to another one. So we want to do the same for our square class. So right here, go ahead and type the same. We're gonna literally type the same, but instead of having initial and final, we're gonna use row and col. So we want to return self.row is equal to the other dot row, and self.col is equal to the other dot col, and this will fix the bug. So let's go to our move class. So yeah, now Python is gonna loop. So right here, it's gonna loop through all of our piece valid moves, and it's gonna compare if that move is actually equal to one of those. Now, how is it gonna compare that move? Well, he's gonna use this equality. Now, if initial is equal to other initial, and as we know, initial is actually a square, so he needs to compare the square. So he's gonna go into this method, and once he compared the initial square, he's gonna do the same with the final one, and then he can return if a move is actually equal to another move. So that's behind the scenes. Hope that's clear. And now we don't need to change anything from here, and it should work correctly. So when I run the file, it was actually hard to see that bug, but now try to move any piece and it will work. So as you can see, now what happens if I capture, I don't know, it actually disappears. Okay. So yeah, it's actually working. Let's move our queens. Try to play with these, well, with what we have, and try to see bugs, because I don't find any bug. Try to move all your pieces. So knight, rooks, knight of other color, move the king, move the bishop, king. I'm gonna eat these. So yeah, I think it's working correct. So make sure to play with it. And yeah, we did it. We actually did it. We actually coded the move, but on the console board. So this is a huge part of the code. We have a huge part of the code, believe me. We're just missing some small things, but we actually have a lot. So if you continue watching this video, feel proud of yourself, because we have done a lot. Believe me, we have done a lot. Okay, let's see. We're gonna continue with our game, coding our game. So the next thing we're gonna code, it's actually something really easy to code. So as you can see, on the structure of our game, on the class diagram, we have right here, the game class, we have a next player attribute that we haven't created. Why do we need that? Because as you can see, we can start with white, but then we can continue playing with white. We don't want that. We want that just when white plays, the next turn will be black, then white, then black, and so on, right? So we're gonna do that right now. So go ahead and create a new attribute. I'm sorry, right here. We're gonna call it next player, and default is gonna be equal to white. The default value is gonna be equal to white. Now we're also going to create a new method and this is not gonna be a render method. So I'm gonna put other methods. It's gonna be next turn. We're gonna receive self as parameter, and we're gonna code the following. So if we're gonna do the if else in one line. So self dot next turn is equal to white if self dot next turn is equal to black, else is black. If it's quite confusing for you, well, just do the if else classic statement and it should work correct. Okay, so we have let me see, we have our next turn method. We also have our attribute. Now we want to check inside of the main loop. We want to check that. We want to check the next player. So it's pretty simple. We just need to check the following. So inside the click event, we want to check, let's see. I want to check if it's a valid piece, color. So we want to check if the piece dot color it's actually equal to the game dot next player. And if that's true, we can do this. I think that's all. Now remember, we have an attribute here, color, and the piece in the piece class, and color is basically white or black. And inside of our game, this attribute is actually the same. It's gonna be white or black when we change it. So it should work. It should work. So let's try it. I'm gonna save the file and run it. And we should be able to move the white pieces, but we shouldn't be able to move the black pieces. So let's see. Yeah, as you can see, I cannot drag it. I cannot drag it. So try it yourself. I'm gonna make a move. Okay, we're missing that. My bad, we're missing that. We need to change of player when we do a valid move. So right here. So right here, I'm gonna put next turn, and it will be a game dot next turn. Now we should have, it should work. So I'm able to move the white pieces. Now I'm able, why I'm able to, what is happening? What is going on? Okay, game dot next turn, let's see. Game dot next turn, self dot next turn. Oh, yeah, that's the problem. This is not next turn, this is actually next player. Oh my god. So this is next player. Now this should work. Pretty sure it should work. Now I can move the white pieces, and now I can move the black ones, and I cannot move the white pieces. So yeah, we have implemented turns on our game. Pretty cool. Pretty cool. We're almost done, actually. Okay, so let me tell you what we are gonna do next. We already did the hard part, which was this method, the calc moves. Now we're gonna do the following. The first thing we want to do is actually, remember I told you that we have a reference to a last move. We have an attribute last move inside of our board class. That's because we want to draw this last move. So that's the first thing we want to do. Then, let me see. Then we wanna create a new method called show hover. You'll see what I'm talking about, but that's the method that we want to create. Pretty simple, don't worry. Then we want to create the theme class. So if you remember at the beginning of the video, I showed you that I was able to change of theme from blue to brown and green and gray. Those were my possible, well, themes. So we're gonna create those, and we're also going to add some sounds. So we're gonna do that, and we should have, by the end of this section, we should have a pretty decent game. We're gonna be missing some things like the passant, the castling. We're gonna be missing checks, So okay, let's start by creating, not creating, but by showing this last move. So remember, last move is set to the when we move a piece. So we already did that, and now we want to show it. So right here in the show methods, we want to create a new method. We're gonna call it show moves, show last move. I'm sorry, show last move. We're gonna receive self as parameter, and we're gonna ask if the self.board actually has a last move. So if it has a last move, we want to do the following. We want to save in a variable initial the self.board.lastMove.initial. I'm gonna copy this, and here we want to do the same with final. So the first thing we want to do is save the initial square and the final square, because we're going to be rendering the last move from the squares, right? So we're going to do a for loop. So go ahead and type for position or pos in, and I'm going to put a list, an explicit list here, initial comma final. So we're going to loop initial and final. And right here, we want to do the following. So we want to save a color. We want to do the same as we did here. So I'm going to actually paste it. I'm going to delete these lines of code. But the structure is the same. We want to save a color, then a rect, and then a bleed. So the color is going to be equal to 244, 247. This is RGB format. And 116 if the pos.row plus the pos.col model2 is equal to 0, else the color is going to be 172, 195, 51. So this is the same that we've done on previous renders. And yeah, remember, position is either initial or final, and we know initial and final have some attributes called row and col. So we can do this. Now we have the color. By the way, these colors, we're gonna save them on our theme class. But for now, we're going to hard code these values. Okay, so now the rect. So rect is gonna be equal to pos.col times square size. So remember, x-axis, where are we gonna start on the x-axis? Then pos.row times square size, where are we gonna start on the y-axis? Then the width, and then the height. So that's the rect, and the bleed will be, we need to pass surface. We want to receive surface as a parameter, and we want to type the following. So surface, Pygame dot.draw.rect, and we want to pass surface, color, and rect, and that's it. We have it. Now each time we do a move, we're gonna show it. So let's see. We need to call this from the main class. So let's see. We do a move when we release the click. So here. So we actually want to show it right here, in between the show background and the show pieces, because we want to render the move on top of the background but below of the pieces. That's why. So game dot show last move on screen, and this should work. So let's see. Whoop, it's not working. Let's see why. Is it game? Yeah, it's game. Show last move. I think I know the error, and it's because we're not showing it right here. So let's see. We want to show it on top of the background, but do we want to show it on top of the moves? No. So we're gonna put it here. Game.show last move on screen. This should work. This should work. Yeah, awesome. This looks pretty nice. So Make sure you play with it. Oh, okay, we're having a bug here. Yeah, when we are doing the mouse motion, it's actually not showing. So we're gonna fix that right now. So in mouse motion, let's see, right here, we want to do game dot show last move on the screen. I think that's all we need to do. Oh, this wasn't mouse motion. This is actually click. Yeah, we're missing mouse motion. So right here, it will be game.show last move on screen, and I think we have it. Yeah. So let's see. I have the last move being drawn, being bleeded on the screen. Now, as you can see, if I hover, it works. Now it changes. This is the last move. Now this one. Awesome. This is pretty cool. Pretty cool. I like it. So try to play with it. Like, we have a pretty big chunk of the code now. So yeah, play with it. Let's see what happens if I capture a piece. Then I capture this one. Okay, it's working. Awesome. Okay, so let's now create the method that I told you about, the show hover. So go ahead and type def show hover. We're gonna receive self as parameter, and we're gonna pass it for now. Now these methods are mostly design methods. So if you don't care about design, well, I think you can skip this. But yeah, I think it's pretty cool to have these methods like show last move, show hover. You'll see what I'm talking about. Show moves, all that. It's actually pretty cool. So okay, for show hover, we want to create a new attribute, and we're gonna call it hovered squared. This is gonna be equal to none as default. Now inside of the other methods section, we're gonna create a new method called set hover. We're gonna receive self as parameter, and we're gonna receive a row and a col. And we want to set the hovered square to be equal to the self dot squares. I'm sorry, so to the self dot board dot squares in the position row, in the position column. There we go, and that's it. Okay, what else? Let's actually code the show hover method. So this is gonna be pretty simple. So if self dot hovered square. So if we have a hovered square, we want to do pretty much the same as we did here. So we're gonna have a color, we're gonna have a rect, and we're gonna have a bleed. So the color is gonna be always 180, 180, 180. The rectangle, it's gonna be, instead of pause, go ahead and change this to self dot hovered square. Here it will be dot col, and here it will be dot row. And when we bleed it, okay, we need to receive surface, and that's it. We have it. Now we're missing some things. We're missing the set hover call. So we're gonna call the set hover from the main class. So we want to set a hover inside the mouse motion. Let me show you. So right here, we want to set it outside the dragger, because we don't care if we're dragging a piece. We want to hover a square when we have a mouse motion on it. So we're gonna type game.setHover, and it receives a row and a col. So let me see, we want to create them right here. So the motion row is gonna be equal, as always, this is always the same. So event.pause in the position 1 / square size. We are converting from a coordinate to a board position, and then we have a motion row call. I'm sorry, this is gonna be equal to the event.pause at the position 0 divided by square size, and now we can set the hover to that motion row and motion column. That's it. Now we need to show it. So we want to show it. Let's think about it. We want to show it. I think we want to show it right here. So we game.show hover on screen. This is like the order we want to show things. So first the background, which is the first thing we want to show. On top of the background, we want to show the last move. Then we want to show the moves. Then we want to show the pieces. Then we want to show the hover, and then finally we want to show the dragger piece, the piece that we are dragging. Okay, so in mouse motion, and I think that's it. We also need to call it right here. Let me see, right here. We're gonna put game.show hover, and you'll see what hover is, because I don't know if you understand what show hover does. So I think I didn't explain it, but okay. Okay, this is show hover, but it's not gonna be like this. We don't want the rect to be filled. So it's pretty simple. Right here, on the bleed part of show hover, we can actually send another param, an optional param, which is, let me see, border radius. This one. No, I'm sorry. Width. Yeah, it will be width. It will be width. So if no width is specified, the rectangle is going to be filled. But if we specified, so width equals 3 pixels, the square is not going to be filled. So now, as you can see, I don't know if you can see it, but we're hovering the square, and it actually looks so cool. So that will help us, well, know where is our mouse, you know? Pretty cool. You can change the color if you like, but yeah. Okay, we did show hover. I told you it was gonna be pretty simple, and now we're gonna start creating some more classes. So if we go to our class diagram, we're gonna be coding all these. We're gonna be coding these classes. So we're gonna be coding a configuration class, which is gonna have 2 reference, one to a theme, one to a sound class. Theme class is gonna have 3 reference to the color class, and sound class, it's gonna be pretty simple. Actually, these 4 classes are pretty simple. So let's go ahead and code them. So we're gonna start by creating the config.py, the configuration class. So class config, we're gonna create our init method, pass it for now. We're gonna have a method called change theme. We're gonna receive self as parameter. We're gonna pass it for now. And we're gonna have a private method called add themes. We're gonna receive self as parameter, and we're gonna pass it. So this is the config class. We're also going to create the theme class, so theme.py class theme. We're gonna create an init method, pass it for now, and yeah, we actually don't need methods inside of this class. We also are going to create a new class called color.py. So go ahead and create it, class color. We're gonna have an init method. We're gonna pass it for now. We're not gonna have methods in here, and we're missing the last one, sound. So sound.py. We're gonna be coding those classes in a moment. They are pretty simple, believe me. So class sound, same, the init method, pass it for now. So yeah, they are pretty simple, you'll see. So okay, we're gonna start with the configuration class. No, actually we're gonna start from the bottom. So from the simple classes, so color and sound. Then we're gonna code the theme, and then we're gonna code the config. So let's go ahead and start with the color. Pretty simple file. We're just going to receive light and dark. That's it. and we're gonna put self.light equals light and self.dark equals dark. Pretty simple. We have the color class ready. Like literally, this is the file. We can actually close it. Now let's go ahead and edit our sound class. Now, by the way, this class is going to have one method, which is play, which is gonna be responsible of playing the sound. So I'm gonna pass it for now. We need to import Pygame inside of this file, and we want to receive some params, which is not some, just one, which is gonna be the path of the sound. So self.path equals path, and we're gonna have a sound attribute, which is gonna be equal to Pygame dot mixer dot sound. So this is going to create a Pygame sound. Okay, so that's why we need to import Pygame. And the code is the following: pygame.mixer.sound, and sound receives a path also. So we're gonna send our path, and inside the play method, we wanna do the following. So pygame.mixer.sound.play, and we wanna play the self.sound. So yeah, here we're creating a Pygame sound, and here we are playing the Pygame sound. So yeah, pretty simple file. Also, we already finished, and we're gonna go ahead and code theme class. So the theme class is going to receive a lot of params. So we're gonna receive a light BG or light background, also a dark background. You're gonna see why. Now right here, we're gonna receive a light trace, a dark trace. Let me see, I'm actually going to put this comma right here. So right here, like this, and then we wanna also receive light moves and dark moves. And you'll see why. This will start to make sense when we actually apply it. Okay, so we're gonna do the following. We're gonna create a new background attribute. This is gonna be equal to a new color. So we need to import the color. So from color, import color. There we go. So remember, a color has two properties, light and dark. So we're gonna send the light background and the dark background, and that's it. We wanna do the same for a self.trace. It's gonna be a new color. We are gonna pass light trace and dark trace, and we also wanna do the same for the moves. These are our three references to the color class, as you can see. So color, and it will be light moves and dark moves, and that's it. We have it. We can close this file. Now config is a little bit more long, but it's actually pretty simple. So we're gonna start by importing Pygame. We're also going to import OS, the operating system module, and we want to import from sound, import sound, and from theme, import theme, and that's all. Okay, so right here we want to call the add themes. We're gonna be coding this method in a moment. Then we're gonna have an attribute called index. This is gonna represent the index of the themes. Themes is a list. So actually, let me create it here. Self.themes. It will be default an empty list, but we're also going to have a theme. So these are the themes, but this is the active theme. So it will be the self.themes on the position of self.index. There we go. What else? We need a font, which we're gonna create later. Font, we're gonna leave it there. We have a move sound. So we're gonna have two different sounds, one for the movement and one for the capture. So this is actually a new sound, and the sound receives a path. So the path is gonna be us, the operating system module dot path dot join, and we want to go to assets slash, let me see, slash sounds slash move dot waf WAV. Okay, so we have created our move sound. Now we're gonna create our capture sound. So this is a new sound, and it's gonna be the same. So us.path.join assets sounds capture web. There we go. Okay, we have our sounds. Now we're gonna call the play method inside of our main class. So we've finished with the sounds. Now change theme. So it's gonna be the following: self.index class equals 1, because we're changing the theme, so we're incrementing the index. Then we want to put our index to be equal to the module of this value, of the index value, module the len of the self.themes, because we can hard code this. So for example, we're gonna have, I think, 4 themes as default, but if you want to add more, well, this code will let you add as many themes as you want, and this will always like choose the next one. And if you reach the final like theme, this line of code will make themes restart. Like you're gonna choose the first theme. I don't know if I'm being clear. So let's suppose we have a T1, T2, T3, and T4. These are themes, right? So if we increment the index, we're gonna pass from this theme to this one, and so on, so on. But if we are on the last theme, well, we cannot increment the index. So this line of code is gonna make the theme 4 next theme to be the theme 1. This is what this line of code is doing. So hope that's clear. And then we can actually set the theme to be equal to the self.themes in the self.index. Nice. Okay, now we're gonna create the themes. So we're gonna have a green theme. We're gonna have, this is the default theme, so we already have this one. We're gonna have a brown theme. We're gonna have a blue theme. You can create as many themes as you want. And we're gonna have a gray one. You can create more if you want. I'm gonna go with these 4. Now here we're gonna add those themes. So self.themes equals green, brown. Actually going to do this in one line. Yeah. So brown, blue, and gray. There we go. Now we want to create them. So let's see. For example, the green theme, we already have these colors, if you think about it. So it starts with the background, so light BG and dark BG. We already have that inside the game class right here. Remember? So I'm gonna copy these. Where is it? Right here. So this is the first param. Without the color, this is the first param. Then we want to have the dark background, so this one, which is the dark green. Where is it? Here. I'm gonna paste it. Then we want to have a light trace, so this is gonna be the last move. Color. So this is the light one. I'm gonna copy it and I'm gonna paste it right here. Then the dark one, so it will be this one, and I'm gonna paste it. Then we want the light moves, so that will be the red, the red color that we use for showing the valid moves. Where is it? Is this one. So this is the light one. So like this. And then the dark one, which is gonna be this one. There we go. So that's the green theme. Now let's go ahead and create the brown, the blue, and the gray one. You can skip this if you don't care about, well, creating some themes. But okay, the light background is gonna be 235, 209, 166. The dark one is gonna be 165, 117, 80. Then the traces, so 245, 234, 100. Then we have 209, 185, 59. And we're gonna use the red for all. So same red. There we go. Now we have the blue theme. Let's go ahead and create the blue theme. So it will be 229, 228, 200. Then the dark background is gonna be 60, 95, 135. Light trace is gonna be 123, 187, 227. Dark trace is gonna be 43, 119, 191. And we're gonna have the same moves. So red moves. There we go. And last we have the gray one. So it will be 120, 119, 118. The dark background is gonna be 86, 85. By the way, I'm copying these values that I had on another file, but you can use whatever values you want. This will be 99, 126, 143. Then the dark trace is going to be 82, 102, 128. And then we are going to have the same red color. Okay, so we have our themes. Now the next thing we want to do is actually, instead of hard coding those colors, we're gonna make them variable depending on the theme we have. So we're gonna create a new variable. This is gonna be the same for all, basically. So theme equals self.config. We need to create that attribute dot theme. So right here, go ahead and type self.config equals config. We want to import it. So from config, import config. Now we have the theme right here. So self.config.theme. And now the color. So I'm actually going to change that if statement. So color is going to be equal to the theme dot background light if the row plus the col model where is it, model 2 equals 0, else theme dot background dot dark. And this line of code is going to replace all these. Let me actually put a comment here. So rect, and right here bleed. There we go. So we have it here. Now the show pieces, we don't need to change it. Now show moves. So same thing, we're gonna create a variable theme, which is gonna be equal to the config.theme. And the color is gonna be equal to the theme dot moves dot light if this happens, else is gonna be the theme dot moves dot dark. I think we call it moves. I don't really know. Let me actually check. Yeah, moves. Okay, and we are ready with this one. Now the last move also needs some editing. So theme equals self.config.theme. And same thing is gonna be theme dot, is this the trace? Yeah, this is the trace dot light. And then we want to put theme dot trace dot dark, and we have it. So instead of hard coding the colors, we are basically making them variable. So if we change the theme, all colors are gonna change. Now we want to actually change the theme. So how we're gonna do that? With our keys, our keyboard keys. So right here, I'm gonna put key press. This is another type of event. So go ahead and type elif event.type equals Pygame dot key down. And now here, so this depends on you, but I'm gonna do the following. So if the event.key is equal to pygame.k_t, this is gonna be for changing themes. We want to take our game dot, I think we haven't coded that method. Okay, we're gonna have a change theme method inside of our game, and that's all. We're gonna be coding some other key press events, but for now we have the theme one. And inside of the game, we want to create the def change theme self as parameter, and we want to call the self.config.change theme. So remember, config, where is it? Here, change theme is doing this. So now it should work. When we press the T key, it should work. So I'm gonna run the file to see. Event object has no attribute key. Okay, my bad. This is not event key. This is event type. Okay. So we have the green, well, the green theme. This is the default one. Now if I press T, look what happens. We have the brown theme. Awesome. This is pretty cool. Now if I move, I want to show you also this. We have this last move. This is the trace. If I change of theme, this will be the blue one, and look what happens with the trace. It also changes. So this is variable. This is actually pretty cool. And we have the gray one. Awesome. So yeah, now we have some themes to play with. Pretty nice. And we have finished this section, like this design section. Okay, I actually forgot to also code the sounds. So we're gonna do that pretty quickly. Let's go to our game class. And right here, we want to create a new method. It's gonna be called sound effect. We're gonna receive self as parameter, and we are going to receive one Boolean parameter that is gonna be captured, and we're gonna set a default value to false. So if captured, so if we capture a piece, then we want to call our self.config.captureSound.play, and that's it. Else, so if we don't capture a piece, we want to call the config.moveSound and call the play method. That's it. So we have the sound effect. Now we need to call it. So let's see. Where do we want to call it? We want to call it when we release a piece, right? When we do a move. So right here. So if it's valid move, we want to play a sound, right? So right here, we want to check the following. We want to check captured. It's going to be equal to board.squares in the position released row, comma released call, dot has piece. So this is gonna return a Boolean value if this square has piece. So if it has piece, we actually capture a piece, right? So we have the boolean value. Now we move the piece and then we want to play the sound. So it will be something like game.play sound. No, sound effect. I'm actually gonna call it play sound. Play sound. And we're gonna send the captured. So let's change the name. So instead of sound effect, we're gonna use play sound. Now it should work. So each time we either move a piece or capture a piece, we're gonna hear a sound. Awesome. Nice. 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 It's working. I'm gonna now capture a piece. Awesome. It changes. Nice. So it's working pretty good. I'm gonna hit my king. Okay. Pretty good. Hey guys, Coding Spot from the future here. I already finished the tutorial you're watching, and I just realized that I forgot to code this font. So as you can see, we left a comment here, a font comment here. So we're gonna be doing that, and you can continue with the video. Now you're gonna be seeing a lot of methods that you probably don't have till this point, because remember, I'm from the future. I already finished this tutorial. So don't worry if you see some things different. I just came back to show you what are we gonna do with this font. So let's go ahead and create a new font. This will be self.font, and this is gonna be equal to pygame.font.sysfont, and we're gonna send a name. As you can see, we're gonna send a size, and we're gonna send bold equals to true. So the name of our font is gonna be monospace, like this, monospace. The size is gonna be 18 pixels, and we're gonna send the bold equal to true. Now that we have the font, we can go ahead and use it. So let's go to our game class. Remember, don't worry if you see some things different. Now we're gonna modify our show background. So right here inside of our double for loop, we wanna do the following. I'm gonna put a comment here. This is gonna be row coordinates. So we want to check if col equals to 0. So we're gonna put the coordinates on the first column, and if that's true, I want to create a new color, and this is gonna be color equals to theme.bg.dark if the row model 2 equals 0, else theme.bg.light, and we have it. So this is gonna be the color of our font. Now if you're asking yourself like, what the heck am I doing, this is gonna be responsible of marking the squares, marking the coordinates of the squares. You'll see. Now we're gonna create a label. So label, and to create a label, we're gonna create a new variable called label, and this is gonna be equal to the self.config.font, the font that we previously created, .render, and we're gonna receive a text. So what do we want to render? An anti-alias and a color. So the text is gonna be the string. We're gonna cast this to a string, and it's gonna be the total rows minus the row. You'll see. Anti-alias is gonna be equal to 1, and the color is the color that we just created. Now I'm gonna create also the position, so the label position. Where are we going to render this label? And this is gonna be equal to a tuple, and it will be pretty simple. It will be 5, 5 plus the row times the square size. Now, if this is quite confusing for you, because I know there are a lot of variables here, make sure to grab a piece of paper and literally just replace these values with numbers, and it will make sense. Now, the last thing we want to do is actually bleed our label. So, as always, surface.bleed. The first param is what we want to bleed, so that will be the label. And now we want to pass the position. Where are we going to bleed it? So now, if I run the file, we should see an error. Why is this? So it says invalid destination position for bleed. Oh, did I send the color? Let me see. Whoa, I'm sorry. Didn't see this. Now this should work. And as you can see, we have some beautiful numbers being displayed on screen. Now we're gonna do the same, but with the letters. So let's go ahead and continue with our code. Now we wanna put the column coordinates. And this is gonna be if the row equals 7. We are going to do pretty much the same. So I'm gonna copy this. I'm gonna paste it. Now the color is gonna be the theme background dark if row plus column. So if row plus col model 2 equals 0, else the light background theme. Now the label is gonna be the config font render, but instead of rendering string rows minus row, we are gonna render the letter that is gonna represent our columns. Now if you remember, inside the square class, oh, we actually didn't create it. Let me show you the class diagram. So right here, square, we have something called alpha col. So we are going to create it right now. So right here on top of our init method, I'm gonna create a new dictionary, and this is gonna be equal to alpha col like this. Actually alpha cols, and this is gonna be equal to a set. The keys are gonna be the numbers, and the values are gonna be like the letters. So 0 is gonna be A, 1 is gonna be B, and so on, so on. 2 is gonna be C, 3 is gonna be D, 4 is gonna be E. Then we need the F, 5F, 6, G, and 7H. We're gonna do it until the 7th column. Now right here, we're gonna put self.alphacol, and this is gonna be equal to the self.alphacols, so the set, this set, in the position of our column. So if we have a column of 2, the square is gonna be the C, the column C. Now we're gonna create a new static method. So remember, static methods are accessed with the class, not the object. We're gonna call it getAlphaCol. AlphaCol, you'll see why we need this. We're gonna receive a column as a parameter. We don't need the self, obviously, because we are accessing through the class. And now go ahead and copy the set that we previously created. We can't access it as we don't have the self keyword. So this is going to be pretty much the same. Alpha calls are going to be equal to that. And we are going to return the alpha calls in the position of the column. And that's all. So now inside of our game class, we can render the alpha call. So we're going to call the static method. So we're going to use our square class for it. And this is going to be equal square.getAlphaCol. Alpha call. And we're going to send the column. Now we need to import the squared. So from square import square. And now this should work. We're gonna render it on a different position. So go ahead and clear this. And this is gonna be equal to col times the square size plus the square size minus 20, comma, height. So the height of the screen minus 20. So again, if this is a little bit confusing for you, make sure to use real numbers and you'll see it makes sense. Okay, and now we're bleeding the label on the label position. And now we should see, when I run the file, we should see the coordinates being rendered on screen. Okay, I had a problem. Square has no attribute getAlphaCol. Let me see. Square.getAlphaCol. Why is this? How did I call it? GetAlphaCol. Oh my god. So yeah, getAlphaCol. I'm gonna close this, and now we should see this working. Yeah. Now I'm gonna run the file, and we should see the columns being rendered. And as you can see, we have it. So this looks pretty nice. We have the A1 square, B2, C3. So now we can talk in coordinates. So yeah, we can continue with the video. Now, remember, I'm coming from the future, so you're not gonna be seeing these things being rendered on the tutorial, but this shouldn't affect what we are gonna be doing next. So don't worry, you can obviously leave these coordinates on your board, and this looks just so nice. Now, by the way, if I change the theme, look what happens. So these numbers also change of color. This is so beautiful. So yeah, guys, let's continue with the video. So yeah, pretty nice, pretty nice. What are we missing? We actually have a lot. You've made it so far. Like, look the lines of code that we've typed. Like, this is a lot of code. So we're gonna start adding some small things like the restart function. So right here, that will be a key press event. So I'm gonna copy this. I'm gonna paste it here. I'm gonna put if event.key pygame k_r. This will be for restarting our game. We're gonna call the game.reset that we need to create that method. So right here, go ahead and create a new method called reset. We're gonna call the self. We're gonna receive self as parameter, and this is gonna be pretty simple. We want to do the self.init. We're gonna call the init method. So in other words, we are creating a new game, right? Now, we need to do some other things, because if you remember, we have these variables here. So we're gonna copy them, and we're actually going to paste them right here. Why? Because we are restarting the game, but we are not restarting the values, the variables. So screen, I think screen, we don't need it. Game is going to be the new self.game. Board is going to be the new self.game.board, and so on, so on. So we need to do this. This is important in order to restart our game. So let's run the file to see if it works. I'm gonna play here, play here. So now I'm gonna put my pawns like these, and then I'm gonna press the R key, and as you can see, it works. Now let's check here, and it actually works. I'm gonna try to move the black pieces. It actually works, so it's working correctly. Okay, so let's actually start doing the tasks that we have on our to-do list. We're gonna start with the pawn promotion, then we're gonna code the king castling, so both the queen side and the king side castling, and finally we're gonna code the en passant move. So we're gonna start with the pawn promotion. It's actually pretty simple. You'll see we need to go to our board class, and inside of our board class we're gonna modify our move method. So right here in between these lines of code, after we update our console board, but before we set the piece.move to true, we're gonna do the following. I'm gonna actually put a comment. This is gonna be the pawn promotion. So I want you to understand what I'm gonna do next. So once we have moved the piece on the console board, we're gonna check if that piece was actually a pawn. So that's the first thing. So go ahead and type if it's instance piece of pawn. We are going to call a method that we need to create, which is gonna be called check promotion. And we're gonna send as a parameter our piece, so that will be the pawn, and we're also going to send the final square, so the square where this piece, where this pawn ended. Okay, so let's go ahead and create this method, check promotion. I'm gonna do it, let's see, I'm gonna do it right here. So def check promotion, we're gonna receive self as parameter, we're gonna receive the piece and a final square. Okay, now inside of this method is gonna be pretty simple. We wanna check if the final dot row, so the final row of our piece is equal to 0, or the final dot row of our piece is equal to 7. So I'm gonna explain this. So this means that a pawn, our piece, is now ready to be promoted. Why? because let me put you an example. White pawns are gonna promote on the row 0, right? Now black pawns are never ever going to touch the row 0 because they can't go backwards. So we don't need to check the color actually. We just need to check if the row is equal to 0 or if the row is equal to 7. So if the row is equal to 0, we're gonna make a queen, a white queen, and if the final row is equal to 7, we're gonna do a black queen. So we don't need to check the color actually. You'll see. So inside of this if statement, we're gonna do the following. Go ahead and type self.squares in the position final.row and in the position final.call .piece. So we're gonna change the pawn, because remember this is the pawn, this is the same piece as we have here, and this is gonna be equal to a new queen. And remember, queen or any of our piece classes receives a color, so we're gonna send the same color. So that will be the piece.color. And this is pretty much all we need to do. So yeah, pretty much that's all we need to do. I'm gonna actually check it. I'm gonna see if it works. So I'm gonna run the file. And let's see, I'm gonna start moving, let's say this pawn, also this one. So I'm gonna push them to the final rows. I'm gonna capture this rook, and we should see how this pawn promotes into a queen. Awesome. Awesome, awesome, awesome. Nice, pretty nice. So it's working for the white pieces. So let's see if for the black pieces also working. Nice. So we have our 2 queens. So let's see if they can actually move as queens move. So I'm gonna drag it, and as you can see, awesome, this is working. As you can see, we have the movement of the queen. We can move diagonal, horizontal, and vertical. So I'm gonna eat this also here. So yeah, it's working. Awesome. So I told you it was not gonna be hard at all. It's actually pretty simple to implement the pawn promotion. So we're gonna mark this as done, and we are gonna start working with our king castling. So let's go ahead and implement the king castling. So that will be also inside the board class, and we're gonna do it right here. So king castling. Before we check it, I wanna actually create a new method. So let me see, right here below the check promotion, I wanna create a new method called castling. We're gonna receive self, an initial square, a final square, and that's it. I'm actually not gonna code it yet because I just remembered that we need to first modify this method, the king moves method inside of our calc moves method. So this one, we need to modify this one first. Let's start adding the castling as a valid move. So this is gonna be a little bit long, so listen to me. I know this code that I'm gonna do next could be optimized. I know it's possible to do it shorter, but I want to do it this way because I think it's easier for me to explain you. So we're gonna start first by checking. So by the way, let's remember that we are inside the king's king moves. So we're the piece is actually a king. So if not piece that moved, so if we haven't moved, if the king hasn't moved, we can actually apply the both queen castling and king castling. So okay, right here we're gonna start with the queen castling. We're gonna start with this one. So I'm actually going to show you right here. Oh, I have an error. I'm gonna pass it for now. And let me show you. So queen castling will be this one. So like this, castling to the left of our king. So we're gonna code that castling first. So okay, we're gonna create a new variable called left rook, and this is gonna be equal to self.squares in the position row, because the rook is gonna be on our same row, obviously, and the column is gonna be the 0, 1. If we're gonna castle, we are assuming that the left rook hasn't moved also, so it's gonna be on the column number 0, right? Now we want to check if it's instance left rook from rook. So if it's actually the rook, the one that is there, we want to now check if that left rook dot moved. So if it hasn't moved, so if not, left rook dot moved. Now if all of these statements are true, then we can do the queen castling. So queen castling will be a valid move for both the rook and the king. Now I'm gonna explain you the algorithm that I'm gonna use. So we're gonna loop through each column. So from here, from where we have our knight to where we have our queen, and we're gonna check that these squares are actually empty, and we want to actually add the castling move, the queen side castling. So let's see, we're gonna do a for loop. So for, I'm gonna use C as column because we're already using call, so I can't use call. In range 1 to 4. So these are the columns that I show you a moment ago. Now 4 is excluded, so we're gonna check until the third column, and we want to check the following. So if self.squares on the row and on the C dot has piece, we want to break the loop, and this is gonna pretty much exit all the if statements, or in other words, castling is not possible because there are pieces in between. That's what this if statement does. So I'm gonna copy this comment, I'm gonna put it here. Castling is not possible because there are pieces in between. Okay, so we break. Now, if that's not true, we want to now check if we are on the column, the C number 3, because that means that we finish with the for loop, and that means that we can add the castling as a valid move. Okay, I'm gonna pass it for now, because for this I wanna create a new attribute inside of our king class. So go ahead and open the piece file, and inside of our king class I'm gonna create two new attributes. First one is gonna be left rook. This is gonna be equal to none as default, and also right rook, and this is gonna be equal to none as default. Now we need these attributes because we wanna have a reference from our king to the rook. So you can think this, that instead of having one move, like the king is having a valid move, it's two moves in one. So we have to move the king but also the rook. That's why we're making a reference. Okay, so now if we manage to reach inside this if statement, we can actually add the left rook to our king. So piece dot left rook is gonna be equal to left rook. Remember, this piece is actually our king, so I'm gonna put a comment here, adds left rook to king. Okay, next thing, we're gonna create the move for our rook. So rook move, and then we're gonna create the king move. So rook move is gonna be the following. So we're gonna create an initial square as usual. This is gonna start at row and at the column equal to 0, and a final square which is gonna be the same row, but the column number 3. So if you see our board, we want this rook to finish right here, and this is column number 3. So let's continue. This is the final move, and then we can the final square, I'm sorry, and then we can create a new move, and this is gonna be initial, comma, final, and finally we can append, or we can add to our left rook this new move. So add a move, and that's all. So we did the rook move. Now we're gonna do the king move, which is pretty much the same. So I'm actually going to copy these, because we're gonna have an initial, a final, a move, and we then wanna, well, append that move. So initial is gonna be row, comma, call. Final is gonna be row, comma, 2. The move is initial and final, and then we wanna put our piece dot add move, the new move, and we did it. So we have the queen castling. I'm going to close this. Now this is the part that I was talking about. This is actually not optimized, because we're gonna literally copy all these and paste it for the king castling. We're gonna do the same. Now again, I'm repeating this code because I think it's clear for you to understand what are we doing on the queen castling and also what are we doing on the king castling. But I want you to know that you can merge both blocks of code. So I'm gonna paste all these, and now instead of left rook, go ahead and replace all the left rook for right rook. Then instead of having the 0th column, we want to have the column number 7. Now, by the way, I'm missing something here. So left rook is actually equal to this, but dot piece. I missed the piece. The same here. So dot piece. Now we right rook is equal is instance of rook. This is okay. This is okay. This is the same. Now the for loop, we need to change the for loop, because now it's gonna be from 5 to 7, and this is gonna be the same. And then we can check if c equals 6, and then we're going to add the right rook to our king, and then we have the rook move. So this is gonna change. So it's gonna be row, comma, 7 for the initial, and row, comma, 5 for the final. Initial, final, this is the same, and we're gonna change this one, because final is gonna be now the column of the final square is gonna be now the 6 column, and that's it. So yeah, we finish adding the castling as a valid move. Now let's see, let's go ahead and code this method, which is actually going to be pretty easy. You'll see, it's gonna literally be one line of code. So we want to return the absolute value of the initial dot call minus the final dot call equals to 2. Now let me explain. In other words, we're returning if the king moved by 2 squares, and that means that we're castling. The only way that the king moves by 2 squares is because we're castling. There's no other possible way that our king is gonna move 2 squares without castling. So now right here, we want to check if this instance piece from king. So if it's a king, we want to check if the move was a castling. So if self.castling, this is the method that we just created, and we're gonna send initial and final. So if this is true, if the absolute value of the difference is actually equal to 2, we want to take the difference, but this time without the absolute value. So final dot call minus initial dot call without the absolute value, because we need the sign for this. And then we're gonna put rook is gonna be equal to piece. So our king dot left rook if the difference is less than 0. So in other words, if the king moved to the left. Else we want to set this variable, this rook variable, to be equal to the piece dot right rook. Why? Because we want to move our rook. So we're gonna do something called recursion here. We're gonna call again our move method, but this time with the rook and with the final move of our rook. So that will be rook.moves in the final position. So I know this might be a little bit confusing, but let me explain. So the first thing that we're doing, we're actually moving the kings. So the king is actually moving 2 squares. Now we're checking if the king actually moved 2 squares. So that means that we have castled. Now, if we castled, we need to know if it was a queenside castling or a kingside castling. That's why we need this if statement, checking if the king was going to the left or to the right. And finally, we're calling again our move method, but this time with the new rook that we get from the if statement. And we're sending as a move, because remember we have a parameter of move, we're sending the last move. And the last move is actually, let me show you, where is it? Right here. It's actually this one that we added inside of the king moves method. So hope that's clear, and I think this should work. So I'm gonna go ahead and run the file. Okay, so I'm going to do the following. I'm gonna try the king castling with the white pieces and the queen castling with the black pieces. So let's start developing our pieces. I'm gonna put this here. So we should see, okay, it's working. We are seeing this as a valid move, so 2 squares as a valid move. And now as you can see, I can castle. Awesome. Now I'm gonna try the queen side castling, and it also works. Awesome. Now I wanna try what happens if I move my king. We shouldn't be possible to castle. So let's see. Pretty quickly I develop my pieces, and as you can see, it's not possible. So pretty good. I'm going to put it here, and it's also not possible for the black pieces. Now I want to move my rook. Let's see. I'm gonna develop the pieces. I'm gonna move this rook, also this one, then this one, and we should see that the castling is not possible. So yeah, as you can see, it's not possible. I'm gonna move this, and this one is also not possible. So although we haven't moved the king, we moved the rook, and that's why the castling, well, it's not possible. So pretty good. I think we did it. It's all working correctly. I'm gonna mark this as done, and now we can start coding the pawn ampersand. Now, before we do the pawn ampersand, we're gonna be coding the checks, because I think this is a really important thing of our game, and I want to start coding this before we code the pawn ampersand. I want to have checks first. So let me show you what I mean by checks. Let me run the file. So let's suppose we are on the following situation. Let's say I move my bishop right here, and the next player to move is the one with the black pieces. Now, as you can see, this pawn right here is pinned, right? Because if I move it, obviously my bishop could capture the king. Now, that is not possible. So I want to somehow, let's do again that situation. I want to somehow make this pawn to have no valid moves. So the idea, what we are going to be coding next in a moment, the idea is that when we have this situation or any other situation similar to the one you can see on screen, we shouldn't be able to move a pinned piece. So in this case, this pawn. So when I drag this pawn, we should not see these 2 squares as valid moves. Now, let's suppose we have now this situation. So let's say, let me think. Let's say we have this situation. So black pieces, black king is in check. Now, I want that on this situation, the only valid moves for black are the following ones. So the knight right here blocking the check, or right here blocking the check, or this pawn right here blocking the check, or the bishop, or the queen right here. So I want those to be the only valid moves for black. So yeah, we're gonna start coding that. As you may see, it's gonna be complex. It's a complex code. You can try and code it by yourself. But yeah, it's quite complex, but it's definitely something that we want to have on our game. And once we have finished this, we're gonna continue with the pawn and passant moves. And we're ready to start coding our AI after we do these two things. So, okay, let's start coding the checks. For this, we will need to create a new method inside of our board class. So I'm gonna create it, let me think, right here. I'm gonna call it in check. So go ahead and type def in check. We're gonna receive self, we're gonna receive a piece, and we're gonna receive a move. I'm gonna pass it for now. So let me actually show you what I wanna do, and then we're gonna start coding it. So let's say we are on this situation again, right here. I wanna do the following. When I start dragging a piece, so in this case, this pawn, when I start dragging this pawn, I wanna check if after any of these two moves, so for example, let's say I'm gonna move it right here. So I want to check if when I move the pawn to this square, I'm going to check all the white pieces possible moves. And if any of the white pieces has its final move with the enemy king as a piece, I want to invalidate this move. So let me explain again. Each time I start dragging a piece, I want to check. For the other color pieces, I want to check if any of those pieces final move is actually having the king as a final target, as a final piece, because that will mean that we are in check, and I want that specific move to be obviously invalid. So I hope it's more clear now. We're gonna be coding that right now. Now, in order to do that, we need to change some things. So if you see, for example, I'm gonna go here. If you see the straight line moves, we're adding a new move, but as you can see, the final square, we're not adding a piece, although we can, right? Because we have the param, but we're not adding that piece. So we're gonna go ahead and add some pieces to the final moves. So we're gonna start with a pawn. Now vertical moves, we don't need the final piece because we cannot capture on vertical moves. So we're gonna do it on diagonal moves. So right here, go ahead and type final piece. And we need to create this variable. I'm gonna create it right here, and final piece is gonna be equal to the self dot squares impossible move row impossible move call dot piece. That will be the piece. So in other words, we're taking either none as a piece here, or we're actually taking a piece. And then with this final piece, we want to check if that is actually the king of the other color. So that will be a check. So hope that's clear. I'm actually going to copy this line of code because we're gonna paste it a lot of times. So in knight moves, we're gonna do the same. Create a final piece variable and just put it here. Final piece. And actually, do you remember I put this comment some time ago? That's what we're doing right now. So final piece. So okay, knight moves. Now we're gonna go inside the straight line moves. So right here, I want to create the final piece variable, and I want to send it here. Also, by the way, I don't know why we did this with if statements only, but this should be a if. There's one bug. The other time I was playing alone, and I got a bug that was because of this, because of the if statements, because this should be a if instead of if. I don't remember the bug actually, but it had a bug. So make sure to put the if keyword instead of the if one. Okay, now let's go to the king moves. Okay, we actually don't need to add for the king moves because a king cannot give a check, obviously. So yeah, I think we're ready to code the in check method. So right here, the first thing we want to do is to create a temp board. Now, we want to create a temp board because we're going to start moving pieces and we don't want to actually move pieces on our original board. That's why we're going to use a temporary board. Now, to do this, we need to import a new model, which is going to be the copy model. And we're going to type copy.deep copy. And we're going to copy our self. Now, remember, self is the actual board because we're inside the board class. So let's go ahead and import copy. Import copy. And by doing this, we're actually copying all the properties of our board. So we're literally cloning our board, but now we can start working and applying the methods that we need to apply for this algorithm to our temporary board and not to the original one. So, okay, we're gonna do that. And also, let me create a new variable here. We're gonna create a temporary piece, which is gonna be the same, the copy.deep copy our piece. Because as I told you, we want to move the piece inside a board, but we actually want to move the temporary piece on the temporary board. We don't want to touch our original objects. Okay, once we have this, the next thing we want to do is actually move the piece. So we're going to type temp board.move. So remember, this is a board, so we can actually access any of our methods. So we're accessing this one, the move one. And we're gonna move our temp piece, or let me see the params. Yeah, we receive a piece and a move. So we're gonna receive the temp piece and the move. We're gonna send these two params. Okay, so why do we want to move the piece? Let me actually show you again, because I know this might be a little bit confusing. We want to move the piece because we want to know if after we move the piece there is a check available. That's why we want to move it. So yeah, in this case, let me do it again. In this case, the piece that we're moving will be the black pawn. That's the piece that we're talking about. So we move it, and then we want to check if there's actually a check. So how do we do that? We're going to do a double for loop, as always. So for row in range rows, we're going to loop our board, basically. So for calling range calls, and we want to check if the temporary board, remember we're not using the original one, dot squares on the position row, on the position column, dot has enemy piece, and we're gonna send the piece dot color. So remember, on our example, the piece will be the black pawn, so this will be the black color, and we're checking for the white pieces because we want to know if any of the white pieces has a final move with the king on it. So we're gonna save on a variable p, which stands for piece, but we can't use piece again because we already have it. We're gonna save inside the p the temp board dot squares in the position row, in the position call dot piece. So on our example, this will be, for example, the bishop, the piece that's threatening a check. Now on our temp board, we want to we want to calculate the moves for that specific piece. So the new piece, the bishop on our example, and we want to send the p, which is the piece, the row, and the call. So we're again calculating all the valid moves for our enemy piece. Now we can loop those moves. So for m, we can't use move as we're using it here. So for m in p.moves, we want to check if isInstance. So isInstance, the move.final.piece from king. I'm gonna explain it on a moment, and we're gonna return true if this is true, and outside of both of the for loops we wanna return false, and that's all we need to do. we're missing some things, but this is like the algorithm. Now, let me explain you this part, this code. So, as I told you, we're calculating the moves for our enemy piece, and then we're looping each move, and we're seeing if the final square, remember a move is an initial and a final square, if the final square has a piece, which is the king. So in other words, there is a check. So in other words, we don't want that move that we're sending to be valid. And we're gonna do that in a moment. But yeah, so hope that's clear. I'm gonna show you the last time what we're doing. So I'm moving right here. Yeah, that should work. I'm moving my bishop right here. Now, when I drag these, I want to check for each valid move. I want to check if after I move it, remember, we're moving it on our temporary board. I want to check for each of our enemy pieces. So let's say I'm checking the bishop one. If any of the valid moves, so any of the red squares has a king on it, and that will be invalid. So I think it's clear now. So, okay, we have this method. Now, inside of calc moves, we need to start doing some things. So, let's start with our pawn moves. Now, before we add the move, we want to check if that move actually leads to a check. And if that's true, we don't want that move to be valid. So, we want to check, let me put a comment, check potential checks. So we're gonna do an if statement. So if not self dot in check with the piece that we are analyzing the moves, and we need to send a move. So the one that we previously created. If not in check, we can actually add the move. Now, this is not gonna work yet, but this is the idea. Now, why will this not work? Let me show you. So actually, I'm gonna show you the following. Where is it? Right here. So inside in check, we're calling calc moves, as you can see. But also inside calc moves, we're calling in check. So this will lead to an infinite loop, and this will damage our program, obviously. So we need to do the following. Let me actually explain it. I'm gonna create a new param for our calc moves. I'm gonna call it bool. This is gonna have a default value of true. So remember, calc moves is being called from two different parts. The first one is inside this method, so the inCheck method, but also we're calling the calc moves right here when we click a piece. Let me show you. Right here, we're calling also the calc moves. Now, right here, when we are going to move a piece, we actually need to check if moving that piece leads to a check. So here, we're gonna have our bool as true. We're gonna leave it as default. Now, inside of our inCheck method, however, we don't want to actually move this piece. Like, I mean, think the following. Right here, we're just checking. We just want to know if the final piece of a final move is a king. We don't want to actually move that piece. So we don't want these method calc moves to call the inCheck method again. So we're gonna send the bool as false. I know this is confusing, but it might start to make sense when we code it. So now we just want to call our inCheck method if bool. So if bool is true, and we can do this. Now, if bool is not true, we can actually just add the move. Like literally copy this and paste it right here. Remember, bool equals to true when we're calling the calc moves from the main class, but bool is equal to false when we're calling it inside the inCheck method. So in other words, when we call it here, we don't want to actually check again if there is a check for this piece. I know it's confusing, but it's the way that I thought about it, and as I told you, this is a complex code. So yeah, This is literally the line of code that we need, and we can actually paste it inside of the other methods. So inside the knight moves, straight line moves, and king moves. Now I want to show you. Let me see if this actually works. So I'm gonna show you. I'm gonna run the file right here, and we should see that it's not possible moving this pawn right here. So I'm going to set up the same situation that we had. Now, as soon as I drag this piece or try to drag this piece, we should see no valid moves because this piece is pinned. And as you can see, it's working. Awesome. It's working, as you can see. Awesome. Now, let me show you another case scenario. So let's say we have the bishop right here. And now I'm going to move this pawn here. Now I'm going to move this bishop here. Now I'm going to move this pawn right here. And now I want to move this bishop here. Now, this pawn shouldn't be able to move also. And as you can see, it's not possible. It's working correctly. However, the other pawns are able to move, as you can see. Awesome. So pretty good. Now we just need to add that same line of code. So this one inside the other methods. So for the diagonal moves, we're going to do the same. So instead of appending the new move, we're pasting our code, and this should work also with diagonal moves. And we're ready with our pawn moves. Now inside the knight moves, we're going to do exactly the same. So go ahead and erase this, paste the if statement. Now inside the knight moves, however, we need to add one small thing, and it is the following. Right here, we're going to add an else, and we're gonna break it. Why do we want to do this? Because we're inside a for loop, and basically we're telling this method like, okay, if the specific knight that we are talking about is actually in check, so this is what this else represents. If it's actually in check, so if we move the knight, our king will be pretty much dead. We want to break the loop. Like, we don't want to add any more moves because it's pinned. We don't want to add moves. That's why we need to put this else break. We're gonna do pretty much the same inside the straight line moves. So instead of having this, we're gonna paste our if else. I know there is a lot of repeated code. You can actually refactor these methods, but I think I'm good with it. I don't want to overcomplicate myself, so yeah, we're gonna paste it also here. Leave this break keyword, because remember, this represents that it has an enemy piece, so we need to add the move, but also we need to break it. And right here we want to break it, so we are not adding the if else, and I think we are ready with the straight line moves. And the final is the king moves. So right here we are going to replace it with this. Now these are the normal moves for our king, and we are inside the for loop, so we need to do the same. So else break. Now castling moves. This is also a different case because we're moving two pieces, but it's pretty much the same. So we're gonna paste our if else right here, and instead of checking just one piece, we want to check two. So let me think. I'm gonna rename this variable. I'm gonna call it move r for move rook. So go ahead and rename it, and I'm gonna call the move k for move king. And inside we can do the following. So if not self in check piece, which is our king, and not self dot in check. Now instead of piece, we're gonna use left rook. Oh, by the way, this is move k and this is move r. So if by moving both of those pieces we're not in check, so if it's all good to go, we can append the move to our king. So it will be move k. So append new move to king. We can delete this line of code, and also we are going to append the new move. So append new move to rook. So yeah, left rook, add move, move R. Yeah, I think this should work. Now else we want to add it to the king, a new move king, but also to the left rook. Again, I know this is a lot of repeating code, but yeah, you can try to refactor it yourself. Let's see, we need to do the same with this is the queen castling. We need to do the same with the king castling. So I'm actually copying this. I'm erasing these two lines of code. And I'm pasting the code right here. So it will be, let's change the name for move R and move K again. Let me see. So if not in check the king, and if not in check the left, this will be right rook, move R. We're going to take the right rook and add the move R, and we're gonna add the move K to the king, and this should be right rook, add move R, and this should be move K. So we need to change that also right here. I think this should work. So let me think if we're missing something. I think we're good to go. I'm not sure, but okay, let's see. So yeah, hope it's clear with what we just coded. I know it's confusing. This is actually one of the most complex things about this game, checking the checks. So let's see. I'm gonna have a new setup. So it's working. We are able to move the pieces. So try to test it. It should work as normal. So try to test it. I think it's working. Now I'm gonna put in check the black king. Now we should be able to only move this pawn to this square, this knight to this square, or this one, this bishop to this square, or the queen to this square. There are no more possible moves. So I'm gonna start with the pawn. Awesome. We can move it. Nice. We can move the knight. We can obviously not move the bishop. We can't move this pawn. We can't move this one. Okay, I think it's working. Now I'm gonna drag the knight. Awesome. This is awesome, guys. It's working. As you can see, this is not a valid move because we're in check. So we need to block it. This is valid. Awesome. This is also valid. This is also valid, and this is also valid. King obviously can't move. Nice. So this is working. I'm gonna put the knight here. Now if I move my bishop, this knight is not going to have any possible moves because it's pinned. However, if I protect it and I move my, I don't know, let's say I move my bishop here, I can start moving my knight. So it's working correctly, guys. We did it. We basically did the hardest part of this tutorial. And we're just missing the pawn en passant, which is actually not that hard. So if you're confused about it, as I always recommend, grab a piece of paper and try to literally draw it and try to think it your way. If you're thinking on another solution, remember this is not the only solution. This is how I thought about it, but you can think your own solution. Try to do it. I think we can mark this as done. This is a big step. Big step. Awesome. Now we're just missing the pawn en passant, which is actually not that hard. So super cool, guys. We're almost finishing the player versus player game mode, and now we can start coding the final thing of our game, which is the pawn en passant. So I'm gonna actually explain for those of you who don't know what is the en passant move. So let's say, let me think, how can we do this? Okay, let's say I move this pawn right here, this one right here, this one right here, this one, then I move my knight, whatever. Now I want you to see this side of the board. This is called the en passant. When I move, oh, I actually moved my knight. I had to move my pawn. Okay, whatever. Okay, as you can see, we have two valid moves, obviously. Now, en passant is applied when our pawn, the pawn that we are moving, advance 2 squares. So if we put it right here, now if there's any pawn on his row, I'm sorry, not row, but on the adjacent squares of the row, so either right here or right here, and by pawn I mean enemy pawn, this pawn, the enemy pawn, should be able to capture like this. So should be able to advance diagonally and actually capture this pawn. So something like this. So yeah, we're gonna start coding that, and it shouldn't be that hard. So hope it's clear what ampersand is. If it's not clear, make sure to search it. Okay, before we start coding it, let me actually show you what we're gonna, like, what's the idea? How did I thought about it? So again, let's say we are in this situation. So yeah, let's say I move this pawn right here. So what I want to do is the following. I want to add a new property to our pawn class called ampersand. Now, each time we move a pawn 2 squares, so for example, this one, I want to set the property ampersand to true. Now, by the way, I didn't talk about this, but to capture ampersand, you need to do it on the same turn that the pawn actually advanced 2 squares. So okay, let's go back to what I was talking about. So I want to add a new property. Now each time a pawn moves 2 squares, I want to set that property to true, so ampersand to true. And now when we are moving a pawn, so this is going to be inside of our pawn moves method, I want to check the following. For example, let's say I do the following move. I want to check for this pawn that we're dragging if there's any pawns adjacent to me on my same row. So in this case, there are 2 pawns. Now I want to check if their property ampersand is equal to true. And if that's true, I want to add the row below them. In the case of the black pieces, the white pieces will be different. The row below them as a valid move. So right here. Now remember these would have an ampersand equal to false because we are not on the same round. However, this pawn, we are on the same round. Just see that the last move was this one. So the property ampersand of this pawn is going to be equal to true. So I will be able to move it right here. Now, for the case of the white ones, the white pieces is going to be pretty much the same. We're going to check our adjacent pawns of our row. I want to check if any of those pawns have a property of ampersand equal to true. And we can capture, subtracting the row from our white pawn row. So hope that's clear also, and we can start coding it. So let me actually start by creating the property. So right here on the pawn class, and you may start seeing why inheritance is important, because I mean pawn has some properties that we don't want the other classes to have, like direction and ampersand. So I'm gonna call it ampersand. I think it's spelled like this. Actually don't know, but I think this is gonna be equal to false as default. Now let me see inside of our board class, inside of our pawn moves, so inside this method, let me actually close all other methods. Create at pieces, I'm gonna close all. In check, castling, check promotion, valid move. Okay, whatever. I'm going to open the pawn moves. Okay, so inside of here, I want to check if the... Oh, my bad. We're not going to be coding that in here. We're going to be coding it inside the move method. So, do you remember what we did with the castling thing? Like, we checked if a king moved had an absolute value of the move greater than 1, which is, in other words, castling. We're gonna do pretty much the same for our pawn. So right here, we're gonna put a pawn ampersand, and let me see, we want to check if is instance. Oh, actually we can do this inside here, so we can have a pawn promotion and also we can have the pawn ampersand. Yeah, so the pawn ampersand will be if self dot ampersand, we're gonna create this method. So passant, we're gonna send initial, and final. We're gonna do pretty much the same as we did with the castling thing. So if self dot ampersand, I want to pass it. Now else, I want to check the pawn promotion. So this will be inside here. Okay, so ampersand, we can code it right below the castling. It's pretty much the same. It's actually the same. You can actually call this method the same. Like you can name this method like castling or ampersand, because it's gonna be the same. So ampersand, we're gonna receive self as parameter, an initial value, and a final, and we wanna return the absolute value of the initial. In this case, will be row. So be careful. Initial row minus the final row. Yeah, because castling is for the column, but ampersand will happen on the row. Now, if this is equal to 2, we want to change the property of our pawn. So right here, we want to do the following. We want to piece dot ampersand equal to true. In other words, it moved 2 squares, so we want to set the property to true. Now I'm actually going to print, no, right here, I'm sorry, right here, I want to print something like pawn moved 2 squares. I'm gonna see if it actually works. So I'm gonna run the file, and we should see something printed on console when we moved a pawn by 2 squares. So if I move it by 1, it says pawn moved 2 squares. Okay, something's going on. Yeah, I know what's happening. I know what's happening. The thing is that we're calling, let me put the class, we're calling the move method inside of our in check method. Do you remember? So yeah, it's normal. We see a printing statement for every pawn, but this should be printed twice when we move it 2 rows. So if I move it 1, it's printed 1 time, but if I move it twice, you can see it's printed twice. So it's actually working. Yeah, it's actually working. I'm gonna move 1 for this. Yeah. So let's say we have 5 printing statements. Now we have 7, as you can see. Yeah. So yeah, I think it's working. So we're setting the property to true. Now this property, we need to set it to false at the end of the turn. So okay, I'm gonna delete these, and now we can go to our pawn moves method right here, and let me see, we have the vertical moves. So yeah, right here. Yeah, I think, okay, so we have the vertical moves right here, and we have the diagonal ones. I actually want to create a new section for the ampersand. So ampersand moves. So let's see, I'm gonna create a row. So R, because we're already using rows, so R is gonna be equal to let me see. So the row that we want to check for the ampersand in the case of the white pieces is this one. So this will be the 0, 1, 2, 3, the third one, and the fourth for the black ones, so 3 and 4. So R is going to be equal to 3 if the piece.color is equal to white, else 4 for the black ones. Now we want to check if, and we're going to call our static method inRange. So inRange, and we're going to send, let me see, we're gonna send the column. So we're gonna send the piece dot column plus 1. So we're gonna check the if there is any pawn to the right or any pawn. So piece dot call to the left. Oh, but we actually want to divide these, so we're gonna do it first for the left one. So left ampersand, this will be like left ampersand. So if squaring range, but also if the piece dot row is equal to r. So if we are on the row for ampersand. Now if this is true, remember this is left ampersand, we want to check if the self dot squares on the, let me think about it, this will be r, or actually row. We can use row for these, and here we're gonna put col -1. If this dot has enemy piece actually, because we want it to be an enemy piece, has enemy piece, and we're gonna send our piece dot color. Now if it has an enemy piece, we want to check if that piece, so if, and actually I'm going to create a new piece which is going to be equal to self dot squares on the row on the column -1 dot piece. Now we want to check if is instance p of pawn, and now we want to check if the p dot how do we call it, ampersand, the ampersand attribute, ampersand, do we call it passant or passant? I don't know how do you spell these, I'm sorry. So let me see, I think I call it passant with a, yeah, passant. So if ampersand, we can add a valid move, which is going to be the following one, and I'm actually going to copy these, and we also need to check the check, so I'm actually going to copy all these. Now remember, you can actually refactor a lot of code right here. So I'm gonna paste it, and I'm gonna hit some tabs here. Okay, let's think about it. The initial, as always, it's going to be row and col. Now the final piece. Why do we need final piece? Yeah, we need the final piece. It's gonna be the self that squares, not on possible row. It's gonna be actually on our same row, but column -1. This will be the final piece, and the final is going to be equal to a new square. But this is going to be, and this depends. This depends if we're talking about white or black. So we need to create a new variable. I'm gonna call it final, so fr for final r. This is gonna be equal to, let me actually think, this is quite confusing. This is gonna be equal to 2 if the piece dot color equals white, else I think 5. So we're gonna put a final row right here. Hope it's clear, final row. And move col, this will be the col -1, and we're gonna send the final piece. Awesome. So okay, we have the move, we create a new move. Now potential checks, if bool, if not self, in check piece and move. Is it a piece or p? No, it has to be piece, because p is the one that we're gonna capture. Oh, by the way, the final piece is just p. What's going on? Yeah, this is gonna be p. That's it. We don't need to create a new variable. Okay, so we're gonna call the inCheck for our piece, so our current pawn, the one that's capturing the move. So if not in check, we want to add that move, else we want to add that move. Awesome. We're missing some things, but this should work. So this is left ampersand. Let me actually test it. Let's hope this works. Okay, pawn object has no attribute call. Line 142. Board 142. So right here. Yeah, my bad. This is not piece dot. This is actually just col -1 and row. Yeah. I'm gonna run the file again. Okay. It's working. So we should see. Let me see this. Okay, this is working. I'm gonna put this pawn right here. Now we should see as a valid move. In this case, we should see this as a valid move, but we haven't coded yet the capturing that piece. Okay, so it's not working. I'm going to test the black ones. It's also not working. Yeah, we're definitely having a problem. So I'm gonna check the code, because this might be a difficult bug to see, and I'm gonna be right back. Okay guys, I'm back, and you're definitely not gonna believe my bug. It was, oh my god, it was so stupid. I mean, you should not have any error. It was my fault. I'm gonna show you what is it, but let me show you. Oh, I screwed. Let me show you. So right here, as you can see, it's working correctly. Our left ampersand. Now, as you can see, obviously, we're not capturing that piece, but we're adding the valid move. So that's a big step. So I'm gonna show you the bug. It was so stupid. I put here Passant with an E instead of an A, and that's why it wasn't working. So make sure you spell it correctly, and you shouldn't have any problems. So let's go. I'm actually going to close some of these classes. We're pretty much finished. Now we're gonna implement the right one. So this is the left one. Oh my god, it's too much code. You can refactor these, I know. I'm gonna copy these, so I'm gonna paste it here. We're gonna change some names. So right ampersand will be +1. So first of all, if it's in range and row equals to R, this shouldn't change. Yeah, this is not gonna change. Let's see, we need to change all col -1 to col +1. So this will be col +1. Has enemy piece dot color p equals self dot squares. Yep. If it's instance, yep. I'm actually deleting these print statements. This was for debugging. Now we create the new one. Yep. And I think this is pretty much the same. So this should work also with the right ampersand. So I'm moving this one. Now moving this one, and as you can see, it's working correctly. Awesome. Now we're having the problem that if I move this should be the one with the ampersand. Now, as you can see, I have both ampersands, and this shouldn't be possible because we should have only the ampersand for the last move. So we're gonna fix that, and we're also going to implement the capture thing, which is actually pretty easy. So yeah, we have implemented the move, the valid move, and we can actually start capturing. So right here where it says console board move update, remember we're putting the initial equal to none and the final equal to piece. We're gonna do pretty much the same when we have an ampersand move. So we're going to create a new method called let's see, we can call it ampersand. And I actually spelled also this one incorrectly. Oh my god. Let me change that. Is ampersand. So okay, if self dot ampersand, we're gonna send the self. Yeah, we need to call it different, so it will be self dot ampersand capture. So if the capture, if there is an ampersand capture, we can console board update. So this will be, let me put a comment, ampersand capture. We can update it, and it should be not the initial call, but the initial call minus or plus a difference depending if it was a left or right ampersand. So we're gonna create a variable here. I'm gonna call it diff, and this is gonna be equal, let me think, it will be final final dot column minus initial dot column, or yeah, so if this is negative, so if div, now I'm actually going to put the row, like the delta row, this is delta row, and this is gonna be equal to, oh, I think actually we don't need this, we can just put initial call plus difference. I'm not sure. I want you to know I haven't coded this, so I don't know if it's correct. So okay, initial call plus div, this should work. Dot piece equals to none, and the final row final call piece equals to the piece. Okay, now we need to code this one. So ampersand capture. Did we code it? Didn't we code it? Okay, we need to code it. So def ampersand capture. And you know, I'm so sorry, but this is much easier if we do it inside the move method. So we just want to check if we moved our pawn diagonally, and also if the final square is empty. That's all we want to do. So we actually going to create this div variable outside, and we want to check if div is different from 0, because you know, if we're moving straight forward, this is gonna be equal to 0. So we want to check if we are diagonal, if we move diagonal. Now if it's different from 0 and the final dot, not actually the final, the self dot squares on the final row and the final call that is empty, and that's all we need to do. So this should work. Let's hope it works. I think we're missing, yeah, we're missing also the changing the property of the pawns. Let's see, I'm gonna test it for both left and right. So I'm gonna start with the left one right here. We should see, okay, we need to fix this, but we should see when we move diagonal, we should see this pawn disappear. Let's hope. Okay, it's not working. Oh my god, why is this? Again, I'm gonna quickly debug it myself, and I'm gonna tell you the, well, what was the bug, because I don't wanna waste your time like searching for the bug. So I'll be right back. Okay guys, I'm back. It was actually not that hard, so I'm gonna show you what I did. I'm actually going to show you from the beginning. So let me undo all the things I did. And that's it. Okay, so we had this code. The first thing I noticed is that we need to do this just if we are a pawn, like if we're moving a pawn. So I pretty much just copy and paste those lines of code inside the if statement that verifies if we're talking about a pawn. Now the second thing I noticed, and this was the main bug, is that we were asking if the final row and final call is empty. Now it will obviously not be empty because we're setting it right here. You know, like, look, we're setting the final row and final call square to be equal to our own piece. So this will never enter the if statement. Now, what I did was to create a new variable, which I called ampersand empty, and this is gonna be equal to the final square dot is empty. But we need to do this before we set it equal to our own piece, obviously. And now we want to check if ampersand empty. So if difference is different from 0 and ampersand empty, and this should work. Now we're missing what I told you about the property, and we're also missing the sound. Like, we're not displaying the sound, the capture sound. Okay, so as you can see, we have our three options. This one, as you know, is incorrect. And as you can see, I captured the piece. Awesome. And we don't have any piece here. we set it equal to none. So pretty cool. We're gonna do the sound thing right now. So we're actually playing the sound inside of our main class right here. It is capture equals board squares release row release call dot has piece. So this is like a normal capture, normal capture. As ampersand is a little bit different, I'm gonna actually play the sound inside of our move method. It's actually easy. So right here, so this if statement is the one confirming that there was an actual ampersand capture. So we can easily do the following. We can create a new sound. So I'm gonna call it sound equals a new sound. We need to import sound. So from sound, import sound. So sound, this receives a path. So path is gonna be, oh, we need the OS model also. So right here, import OS. Let's see. So right here, want to do os.path.join. I'm actually going to put this here. And I want to put this here. And the path will be the following. It will be our assets slash sounds. I think we call it capture. Yep. So sounds slash capture dot waf. And I think this should work. Oh, okay, we need to play it also. So sound dot play, and this should work. So I'm gonna test it pretty quickly. No file. Okay, so I had a problem with my path. Let me actually confirm the path. Where did we create the previous sound? So in config right here. Oh, okay. We need to access the assets directly. So my bad. We need to access like these asset sounds capture WAF. So I'm gonna test it. What? Okay, it's actually, oh my god, it's actually playing before we do the ampersand. So, and I know why is that. It's because we're calling it from the in check. Do you remember? So I'm gonna create a new param. So I don't wanna waste more time in this. So I'm gonna add a new param like testing. This is equal to false. And when we send it, so right here, we're gonna send the move testing. This is gonna be equal to true. Testing. And now we just wanna play the sound. So right here, if not testing. I know this is not actually good code, but it will solve our problem. Okay, if not testing, we want to create and play it, and this should work. So pretty quickly, I'm gonna move my puns right here. Ampersand, we got it. Awesome. Okay. I'm going to fix the property thing, and then we can test all the possible scenarios for our ampersand, and we finish. We pretty much finish. So okay, let's think about it. We have a last move. We can use that one. I think we're gonna use that for setting the property back to false. So let's see. Where was it that we were setting the property to true? I don't remember. Right here. So I think we're gonna create a new method right here. Let's call it set false on Passant. We're gonna receive self. We're going to basically loop for row in range rows, and for calling range calls, we want to check if the self.squares on the row comma call dot hasPiece. Actually, we can check directly if it's instance. If it's instance, this square piece from pawn. And if this is true, we want to check if the, remember we have a self.last move. So last move should have a final, but before that we want to actually check if we have a last move. So if self.last move, then if self.last move dot final dot piece is not equal to this one, we can take that one. So actually, let me create a piece variable. It's gonna be that, actually pawn, let's call it pawn. And if this is not the pawn, we are gonna set the pawn dot ampersand to be equal to false. So yeah, we're basically checking if it's not the final move. If this is true, we can set that pawn to false. Okay, so we now need to call this method inside of our, I think it's the main function, yeah. So we're gonna call it when we have a valid move. So right here, we can do something. This has to be after we move the piece, because we want the board to have the last move. So we can call the board dot set false ampersand, and this should work. This should work. Let's see, let's do this one, this one, this one. Okay, it's actually deleting both ampersands. So let me actually debug it, and I'm gonna be right back. Okay guys, so I'm back. I actually fix it, but we need to change some things. So go ahead and delete the method that we previously coded. Now I called this one set true ampersand, and we're gonna receive the piece or the pawn that we're gonna set, well, the ampersand equal to true. Now this inside of our main class is going to look something like this. So board.set true ampersand with the dragger piece. This is inside the click release. So you should send it to this, and we want to do the following. It was actually pretty close. So if it's instance, the piece of pawn. If it's not instance, we want to check first that. So if it's not a pawn, we can return, because we don't want to do anything. Remember, this is the piece that we previously moved. Then we want to loop. So we want to do a for loop, a double for loop. We want to check if the self.squares at the row comma call dot piece. So if that piece is an instance of pawn, we want to set its ampersand to false. So we dot piece equals false. Here we're literally setting all ampersands to false. So at the end, we want to just take our piece, the one that we moved, and we know it's already a pawn because we already check it. So piece dot ampersand equals to true, and that's it. Now we can actually delete the thing that we had right here. So we can delete this one actually, and go ahead and delete also the ampersand. So this one, we don't need it anymore because we're setting true the ampersand right here. Now, by the way, this is not a piece, but a piece that ampersand. So make sure you are setting the opposite, not the piece, obviously. Okay, and this should work. We should have our game ready, our PvP ready, the final version. So okay, it's working. Now we should see the ampersand just for this side. Awesome. Now if I try to move it here, obviously I can't, but if I move it here, I can capture that piece with ampersand. Nice. So yeah guys, we have finished the ampersand and we can mark this as done. And now we have finally finished our player versus player game mode. Now I found a bug, really small bug, and it happens when I try to castle. So I'm gonna do it quickly. I was in check, I couldn't move. So I'm gonna move my knight here, and I'm gonna try to castle, and as you can see, I have an error. This is pretty simple. We need to do the same thing that we did here. We want to put not testing inside of this if. So we want to put if self-castling and not testing. And I'm gonna run the file and you'll see this is going to work. Now, there is gonna be a lot of bugs. I'm sure there are a lot of bugs, but it's quite difficult for me to test all possible scenarios, all possible chess scenarios in order to find those bugs. So if you find a bug, make sure to leave it on the comments below and I'll try to help you, but also you can try yourself to solve it. Now as you can see, the castling thing is working, so we'll literally now finish our player versus player game mode. So in the next video, we're gonna be coding the AI, we're gonna be coding from scratch our own AI to play against. And we should have, by the end of the other video, we should have both player versus player and AI game modes ready. So we're literally having our game ready. And as I told you, we should have some bugs. I'm sure we have some bugs. But I mean, in general, the game is working. So I'm pretty fine with it. So yeah, I hope you liked this video. I hope you learned something new. And I'll see you on the next part of this tutorial to start coding our own artificial intelligence to play against. Thanks for watching and I'll see you in the next video.